Hello, hello. Am I audible? Can anyone please confirm? Hello. Can you please confirm whether I am audible or not? If anyone is there, please let me know. Someone please put it in the live chat whether I am audible, whether I'm clearly audible. Is the video all right? Yes, yes. Are you able to hear me clearly? Is the sound coming perfect? Is the video is also okay? Is it coming okay? Huh? So everything is correct, I suppose? Yes, yes. Okay then. All right. Hello everyone. Welcome to the YouTube channel of Agri Addict. And today we are having the marathon class of Basic Chemistry and Biomolecules. So again, I would like to repeat the words told by our seniors. Okay, soil science will definitely give you a seat, but the minor subjects, that is this chemistry and all those chemicals and all, that will give you the rank. So these are very important portions, and this session is being taken solely based on your request. It was not planned. That's why it is a bit late. Like 26, I understand, is a bit late, but it was done solely on your request. We had not planned it earlier, but anyhow, I am very happy to take this class, and I can assure you, you will learn something, and you will learn how to solve the questions, and also you will feel good, because chemistry, I love chemistry, So okay, without much introduction, let's jump into it. I think all of you know me by now. Yes, I did my UG from GKVK, then MSc from CRRI, and then I'm currently doing my PhD at ICAR JRF in the Division of Soil Science and Agricultural Chemistry. So keeping aside everything, let's jump into the star of today, that is basic chemistry. And we all know basic chemistry starts with nothing but atomic structure, right? So atomic structure, we will entirely stick to the syllabus, yes, because teaching basic chemistry of class 11 and 12 in 2 hours or whatever the time is, it is not possible. So whatever is there in the syllabus, we will touch each and every portion of it, okay? And definitely we will go on. So if anyone is yet to join, you can call them. Otherwise, we are starting it. So atomic structure, yes, all of you know, John Dalton. Whatever is important, I will go on marking, and you should know that. John Dalton proposed in 1808 that atom is the smallest indivisible particle. This is the definition given by John Dalton, yes, but it is actually, nowadays we know that it is not correct, because atom is not indivisible, it can be further divided. But it is the definition of John Dalton, who said that atom is the smallest indivisible particle of matter. However, nowadays we know it contains 3 subatomic particles, namely electrons, protons and neutrons, right? So all of us know what is an electron. Electron was discovered by J.J. Thomson, very, very important, negatively charged, and the charge is minus 1.6 into 10 to the power minus 19. Can anyone tell me what is this unit? What is the SI unit of charge? Can anyone let me know? Then moving on to proton. Proton was discovered by Rutherford, and it carries a unit positive charge, that is plus 1.6 into 10 to the power minus 19 C. And finally neutron. Neutrons are neutral particles. It was discovered by Chadwick in 1932. Yes. Can anyone tell me what is C? What is the SI unit of charge? Yes, Coulomb. So here from this slide, what you need to remember? From this slide, you need to remember who gave for the first time the definition of atom, that is John Dalton, that too in 1808. And then you have to remember these three subatomic particles and who discovered that. Okay. So for remembering this, I will tell you a very simple trick. Whoever knows Hindi, it will be very easy for you. I will try to write in Hindi. My handwriting in Hindi is not that correct, but we will try to write. So you can remember it like eat per nach, you know. This is the eat, this is per, this is nach. So this is electron, yes, this is electron that was discovered by Thomson. Here you can see electron was given by Thomson. Then per that is proton was given by Rutherford, and nach, neutron was given by Chadwick. Yes, you can remember it in this way. Everyone has their own mnemonics. This was made by me, so you can use that. Fine. Moving on. There are some uncommon subatomic particles, yes, that have been further discovered after this proton, neutron and electron. So in that, positron is there. Positron is a positive electron. It was discovered by Dirac in 1930. Okay. The neutrino and antineutrino, particles of small mass and no charge as stated by Fermi. So neutrino and antineutrino was given by Fermi, and then meson was discovered by Yukawa and Kemner. They are unstable particles and include pi ions, pi plus, pi minus or pi 0. Antiproton, it is the negative proton discovered by Serge and Huygens. This is not that important, but just for your information, so that anything comes in the exam, it does not feel like kyare ye kya puch liya. There is very less chance this will come, but just for your information, if you read the PPT once, you just have a go through it. Okay. Then we will come to the how we symbolize the atomic number. I think all of you know all of this. These are very easy. So this here you can see this X is the symbol of the element, this A is the mass number, and Z is the atomic number. So you generally we symbolize any atom like this. So for example, here we will take oxygen. So we will write oxygen 16-8. This 8 is the atomic number. This 16 is the mass number. All right. So what is atomic number? Atomic number of an element corresponds to the total number of protons. Yes, total number of proton present in the nucleus, or total number of electron present in neutral atom. Yes, because in case of ions, if it becomes anion or if it becomes cation, the number of electrons will differ. Then it is not the atomic number. But in a neutral atom, we know number of protons is equal to number of electrons. So in that case, it will be the number of protons or the total number of electrons present in the neutral atom. And mass number is nothing but number of proton plus number of neutron. Yes. So from this slide, what questions might come? From this slide, many questions can come. उसमें से सबसे बड़ा है आइसोटोप, then isobar, then isotone. Yes. So isotope, just by seeing the name only you can tell here there is P, so it means same number of proton. So two atoms having the same atomic number, two atoms having the same number of protons, that is called isotope. Okay. Two atoms having the same mass number, that will call isobar. Two atoms having the same number of neutrons, that will call isotone. अभी isotone कैसे निकालेंगे? Very simple. How to find out the isotone? We will just do A minus Z. Because mass number is number of proton plus number of neutron. इसके साथ हम अगर if we minus the atomic number, this atomic number is nothing but it is the number of protons, right? So it is the number of protons. So this and this will cancel out. So it will be the number of neutrons. So in the question you might find there will be two atoms जिसका mass number or atomic number दिया रहेगा. They will ask identify the isotope among the two, identify the isobar among the two, identify the isotone among the two. For finding out isotone, you just have to minus this. For finding out the isobar, you have to look at this. For the isotope, you have to look at this. It is that simple. All right. यहाँ पे एक और term आता है. Another thing is asked in the exams. This also, I think, just by seeing the name only, you can tell me what is this. Isoelectronic species is nothing but same number of electrons. Yes, same number of electrons. So isoelectronic species का एक example क्या होगा? Say O minus, that is, it is having 9 electrons, O minus and fluorine. So these two are isoelectronic species, right? दोनों में 9 electron है. Then you can say O2 minus and this is also isoelectronic species, right? Because दोनों में 10 electron है. Is it clear till now? Is it clear? Can anyone write it? If it is clear, please put a thumbs up. This slide looks very easy, but यहाँ से it has the potential of getting many questions, all right? बहुत सारे question इसमें से आ सकते हैं. So please be aware. All these that I told, isoelectronic, isotope, isotone, isobar, everything is very important from the exam point of view, all right? Moving on, we have come to the evolution of atomic models. So, atomic models, how actually an atom is, how an atom actually behaves. For that, we had various number of atomic models given by different scientists across the century. बहुत सालों से देते आ रहे हैं. What is a model actually? Model or all these things are nothing but we are trying to predict, because actual में atom क्या है वो तो हम देख नहीं सकते ना, we cannot see that. So we are trying to predict through theory. We are trying to predict through models. So someone is telling it might be like this, it might be like this. So you should remember, no model is ever 100% accurate. ये कभी हो ही नहीं सकता. While we were studying soil chemistry, in that we have read the DDL models, right? Diffuse double layer, electric double layer models. In that also, first we saw Helmholtz, then Goey-Chapman, then Stern. So year by year it develops, because no model is 100% able to explain what is happening. So for atomic model also, various scientists across various time of the century, they gave different models and they tried to explain it in their own way. With time, with the advancement of technology, it also enhanced, right? So the first model was given by John Dalton, who we have already seen, who gave the definition of atom also. He was the first guy who dealt with atoms. So John Dalton, he gave the solid sphere model. His atomic model was named the solid sphere model. This is important. What he told? Dalton proposed the first scientific theory of atom, reviving the ancient Greek idea of indivisible particles. In this, what he told? He told atoms are indivisible solid sphere that cannot be created or destroyed. So he told atoms are like this. This is an atom. Okay. So what were the postulates? All atoms of a given element are identical in mass and properties. Compounds are formed by combination of different atoms in only whole number ratios. Okay. This he told. So now if we think, we know that this is not actually correct, because it is not a sphere and it is not indivisible. But at that time, if you see in 1803, this was a breakthrough, because at that time no one had the idea of atom only. So यहाँ से क्या याद रखना है? जॉन डाल्टन याद रखना है, सॉलिड स्फीयर मॉडल याद रखना है, and the time period. All right. Then the next model was given by J. Thomson. Already I told, Thomson also discovered what? Which subatomic element was discovered by Thomson? Please write. Which subatomic particle was discovered by Thomson? Just 2 slides before I told. Electron, right? Again, you can remember it with EAT per notch, yes? So the next model was given by J. Thomson, and his model was named as plum pudding model, yes? How it came into being? J. Thomson, in his plum pudding model, following his discovery of the electron using cathode ray tubes, he was experimenting with cathode ray tubes and he discovered electron, just we read before. Thomson realized that atoms are not indivisible. He understood that atoms are not indivisible and it contains smaller negatively charged particles. Okay, that is electrons. So here what he told? He told the atom is composed of electrons scattered throughout a spherical cloud of positive charge. So it is like plum embedded in a positively charged pudding. So it is like the cake that we eat. In that cake, say these are like the cashew nuts or the almonds. So he told this cake is the atom and these cashew nuts are the electrons. So similarly, it is the plum pudding model. Here, this is the sphere of positive charge and in that electrons are embedded. Okay, this is the second model. Then moving on to the third model was given by Rutherford. It is also called watermelon model. Yes, perfect, Anil Jat. So Ernest Rutherford gave the third model, yes, and it was called the nuclear model. So Rutherford conducted the famous gold foil experiment. I think all of you know the gold foil experiment. If you don't know, I will tell you. He took a gold foil. In that, he sent a number of alpha particles, okay, and he observed. He put a screen around it and he observed. So he saw most of the alpha particles penetrated this gold foil and went on the other side without any deviation, but some particles deviated at an angle, and only one single particle, it deviated at exact opposite, like it came like this and then it again went back in this way. Okay, so alpha particles, we all know alpha particles are positively charged. Yes, alpha particles are positively charged. So from this he concluded कि atom में सिर्फ negative charge नहीं, positive charge भी है. Okay, so he conducted the famous gold foil experiment where he fired alpha particles in a thin sheet of gold. He expected them to pass straight through, but some deflected at extreme angles. Deflection का मतलब है repulsion हुआ है, because without repulsion there will be no deflection. ऐसे deflect हुआ, it got deflected like this, मतलब it got repelled. Okay, so the atom consists mostly of empty space. It mostly is empty, with almost all of its mass concentrated in a tiny, dense, positively charged center, which is called the nucleus. Yes, it is called the nucleus. So the key discovery of this is the nucleus of the atom. Electrons orbit this nucleus at a distance. So यहाँ पे एक बात लिखा हुआ है कि most of the atom is empty space. Most of the atom is empty space. So just to give you an idea, I will give you one analogy. Okay. Say, I think all of you know football now. Football World Cup is going on. Football grounds you have seen. So consider one atom as one football ground. Okay. If the whole of the atom is one football ground, a whole length, full length football ground, then the size of the nucleus is, all of you have seen pea, right? Pea seeds you have seen, matar jisko bolte hain, matar ke dane, pea. So the size of nucleus is half of a pea seed in the center of that football ground. So if the whole football ground is the atom, then the nucleus is only half of a pea seed that is situated in the center. So that much, this is just an analogy to make you understand how much portion of atom is empty and how concentrated is the nucleus. जिसमें the positive and the neutral charge are concentrated. All right. So we have come until Rutherford model. So we are almost on the verge of discovery. Yes. Then came Niels Bohr. Niels Bohr's planetary model. Oh, sorry, यहाँ पे एक और बात बोलना भूल गया. In Rutherford's model, so in key discovery was the nucleus, and electrons orbit this nucleus at a distance. So he told there is one nucleus and electrons orbit at a distance. Okay, but the problem with this model is, if any object is circling another object, right, without any supply of energy, then according to the theory of physics, what will happen? This will continue dissipating energy. और अगर ये dissipate energy करता रहेगा, so what will happen? It will enter into a spiral and finally it will fall into the nucleus. This is the problem with this model. In this model, he told electrons are orbiting across the nucleus, but he did not give any concept of energy level. So क्या होगा? Electron अगर ऐसे ही घूमता रहा around a positive charge, it will continue to dissipate energy and finally energy lose करते 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 it will finally fall into the nucleus and that atom will be destroyed. So this is the lacuna of this model. Then came Niels Bohr. Niels Bohr gave the planetary model. Okay, Bohr addressed the flaw in Rutherford's model because according to classical physics, orbiting electron should lose energy and spiral into the nucleus. The orbiting electrons, it will spiral into the nucleus and get destroyed by applying early quantum theory. So what he told electrons move around the nucleus in specific and fixed circular orbits, which is having specific energy level. All right, and the electrons move without radiating energy. So he told wherever the electron is, that orbit is having a specific energy level and electron will not dissipate any energy and will stay in that energy level. Okay, so in this what he discovered, electrons can jump between these discrete energy levels by absorbing or emitting a specific quantum of energy. So you can see here, one electron is in this orbit, so it is having the energy level of this orbit. If it wants to jump to a higher orbit, it will absorb some energy, and if this electron, if it jumps into this lower orbit, it will dissipate some energy, right? So this was the crux of the Bohr's model. Can anyone tell me this higher energy, this lower energy orbit electron, it will jump into the higher energy level, then it will jump back into the lower energy level and it will dissipate some energy. This principle is used in which instrumentation technique that we have studied? Can anyone write? Which analytical technique is this thing used? That electron will jump to a higher state, it will become excited, then again it will come back to a lower orbit and it will dissipate that energy. We will measure this energy and we will tell, okay, how much of the element is present, how much, what is the intensity. Yes, flame photometry is not the answer. Like, flame photometry is a part of emission spectroscopy. The principle is emission spectroscopy. Yes, very good, Shreyoshi. Very nice. Emission spectroscopy. Yes, this is the principle of emission spectroscopy. Okay, so we have completed all the classical models of atom, and now finally what is in the present, that is the quantum mechanics, quantum model, right? It was given by Erwin Schrödinger, I think all of you know his name, and also Werner Heisenberg. If you have seen Breaking Bad also, you also know who is Heisenberg, say my name. So this quantum mechanical model, it is also known as the electron cloud model. Okay, this is very important. It is also called the electron cloud model, and this theory emerged from the principles of quantum mechanics, specifically the wave particle duality. It deals with the wave particle duality. Until now, in classical mechanics, we were considering electron as a particle. This model told electron can be both a particle and be a wave. It has wave particle duality. It can be a particle, it can be a wave. And the uncertainty principle. All of you know Heisenberg's uncertainty principle. We will read about that later also. So this model is mainly based on wave particle duality and uncertainty principle. So what is the core concept? The core concept is we cannot know exactly both the position and momentum of electrons simultaneously. Electrons do not travel in defined orbits. So they told electron is sometimes a particle, it is sometimes a wave. So it is not at all possible to specifically predict both the position and the momentum of an electron at the same time. Either we can tell the position or we can tell the velocity. It also told electrons do not travel in defined orbits. Okay. The key discovery is electrons exist in orbitals, 3D regions of space around the nucleus where there is a high probability of finding an electron, also known as electron cloud. So all these जो हम लोग पढ़ के आए हैं is class 8, class 9 and everything, there is a nucleus, there are orbits and everything. They told atoms look nothing like that. It is just some electron cloud where there is a maximum probability of finding an electron at a time. It is like that. So you cannot imagine this actually, but still you can imagine it like a nucleus and there is a 3D space around it and there are some electron clouds. In that cloud there is a possibility. Right here you can see this is the nucleus and outside this there is an electron cloud, 3D region of space around the nucleus where there is a high probability of finding an electron. All right. So we have completed the evolution of atomic models. Is it fine? Have you understood it? If you understood, please write yes or put a thumbs up or anything. Then we will dive into the quantum numbers. From this also question comes, yes. Please do not think ke ye sab nahi aayega. We have seen questions from this, okay. So we will also discuss about this very easily, don't worry. So have you understood? Is it fine? Shall we move on? I can see only one yes. Anyone else? All right, we have still a long way to go. बहुत सारे चीज सीखना है. So we will go on. James Chadwick, what? James Chadwick, we told, no? Nach. He is the discoverer of the neutron. Neutron discover किया था. What are you asking? James Chadwick question mark का मतलब क्या है? What do you want to know about James Chadwick? ठीक है, कोई बात नहीं. Let's dive into the quantum numbers. Okay, let's dive into the quantum numbers. What is a quantum number? The motion of an electron in an atom is determined by 4 quantum numbers. Okay, 4 quantum numbers. Abhi, how will we understand that? Say, electron is, suppose I am an electron. ठीक है, मैं एक electron हूँ. These 4 quantum numbers are nothing but my address. ठीक है, my address, but it is becoming increasingly specific. The address that will become increasingly specific. How? We'll see. So 4 quantum numbers are used to determine the motion of an electron. Fine. The number 1 is the principal quantum number. Principal quantum number. This is used to specify the position and energy of the electron in an orbit or shell. This is denoted by n. The maximum number of electron present in any shell is 2n square, right? 2n square. So this quantum number, think of it as the country. I am an electron and my primary address is India. So this India is the principal quantum number. It is denoted by n and it can only have whole numbers, 1, 2, 3, 4, 5, 6, whatever. It can only have whole numbers, and in each of these numbers, the maximum number of electron that can be accommodated is 2n square. So let us suppose take this 2. So the maximum number of electron can be 2 into 2 into 2, that will be 8. Okay. In this, it will be only 2. So it can hold only 2 electrons. It can have 8 electrons. This 3 can have 18 electrons, right? It can have 18 electrons. Fine. Then moving on to the angular momentum quantum number. Angular momentum quantum number. This is like the second level. So India ho gaya. India ke baad the second one, say Delhi. Now I am in Delhi. So this is the address Delhi. What it does? This is also called the subsidiary or azimuthal quantum number. It is denoted by L. It is denoted by L. This is used to describe the subshell. This is the shell. This is the subshell. All right. And what is the range of it? It can range from 0, 1, 2, 3 until n minus 1. Until n minus 1. So if n is equal to 2, then azimuthal quantum number can range only 0, 1 and 2. Okay, is that clear? Then this 0, 1, 2, 3, 4, 5, it corresponds to the subcells S, P, D, F, G, H. I think all of you know this S, P, D, F, G, H because you have seen in the electron configuration like this, right? So this S, P, these are this. It actually denotes the azimuthal quantum number that is denoted by this L. Okay, is it fine? If there is any doubt, कहीं पे कुछ समझ में नहीं आ रहा है, तो please write that in. Okay, put your full attention in this only now. First you understand this, then we will go on to other topics. So we got the principal quantum number, then we got the azimuthal quantum number. So India में है, दिल्ली में है, हमें पता चल गया है. Now we will become more specific. The next what will come? Oh, यहाँ पे एक और बात है. Any subshell is represented by NL notation such that if we write number for n and name for L, thus n equal to L and L equal to 0 will indicate 1s subshell, right? N equal to 2, L equal to 1, it will indicate 2p subset. How? Because here we have written these numbers correspond to these subshells, okay? 0 is S, 1 is P, 2 is D, 3 is F, 4 is G, 5 is H. Fine. And what will be the range? It will be 0, 1, 2 until n minus 1. So if n is 3, it can only be up to 2. If n is 4, it can only be up to 3. ठीक है? Very nice. So here it will indicate this, it will indicate this. ये बस लिखा हुआ है. Now we have come to the shape. The s orbital is sphere shaped. This is very important. It can come directly, the question can come from this. P orbital is dumbbell shaped and d orbital is called double dumbbell shaped. And after beyond that it has many multi-lobe shape. उसका कोई नाम नहीं है. ठीक है? You can just say multi-lobe shape. अब इसका मतलब क्या है? Here you can see this is a spherical orbital, this is a dumbbell shape, this is a double dumbbell shape, and this is a multi-lobe shape. अब इसका क्या मतलब है? In the next we'll understand. So India हो गया, दिल्ली हो गया. Now we have come to IRI. Magnetic quantum number is the IRI. All right. The quantum number denoted by M determines the preferred orientation of orbital in the space. It determines the preferred orientation of orbital in the space. Value of M ranges from minus L to plus L. The value of M ranges from minus L to plus L. So total values of M will be 2L plus 1. It is the number of orbitals in a subshell. Okay. So M equal to 0 का मतलब है it will only have one orbital because minus L plus L everything is 0. In case of L equal to 1, in case of L equal to 1, the M can be minus 1, 0, plus 1. Okay. Because the range is from minus L to plus L, बीच में 0 भी आएगा. Minus L to plus L is the range, बीच में there is a 0. So in case if there is a D subshell, D का azimuthal like L is what? D का L है 2. So its M will be minus 2, minus 1, 0, plus 1, plus 2. All right. In this way, we can find it out. I think it is clear by now. So S subshell will have only one orbital, whereas P subshell will have 3 orbitals. They are identical in energy. यहाँ पे जो लिखा है preferred orientation of orbital in space, इसका मतलब क्या है? इसका मतलब यही है. If you see this S subshell is spherical. You see the sphere from any direction, from any side you see, it can only have one shape. It can only give you one shape. That is why it has only one orbital, and that is denoted by 0. Okay. In case of this p orbital, since it is dumbbell shaped, you can see it has been drawn in only one axis. So it can be drawn in two other axes as well, right? So it can be px, py, and pz. It can have 3. That is why this p's value comes minus 1, 0, plus 1. All right. That is why, what is the M value of P? The M value of P is, and in case of D you can see, it can be 5. Okay. And finally, it is the spin quantum number. Spin quantum number is what? The electron can be regarded as spinning on its axis like a top in clockwise and anti-clockwise direction. This is called the spin quantum number, denoted with a value of half. So it can have only 2 values, either plus half, or it is called the up spin, spin up, or the clockwise, and it can have minus half, which is called spin down or anti-clockwise. So it is like the hostel where we stay. It is like Madhumas. So we started from Delhi, that is the principal quantum number. Sorry, India is the principal quantum number. Then Delhi is the azimuthal quantum number. Then IRI is the magnetic quantum number. And finally, spin quantum number is the hostel that we live in. ठीक है? So these 3 values of M, what we are seeing, no, from minus L to plus L, this will determine the number of subshell present. Okay. So let's check some, let's do some math here. So can you tell me what is the value of S? What is the L value of S? What is the L value of S? Can anyone tell me? Is anyone there or 0? Very nice. Then P is 1, then D is 2, right? So for S, we will have only one orbital. For P, it will be -1, 0, +1. We will have 3 orbitals, right? And then for D, we will have 5. All right? Is that clear? Is that clear? So in this, the electrons will fill up like this. This is having S equal to +½ this is having S equal to -½ this is the L and this is the M. All right, and इसका जो principal energy level है that will be the N. In this D तक है तो we'll have to say N equal to 3 because we have taken until D and D is 2. 2 is N minus 1. So 3 minus 1 can be 2. So without the third shell, like if the N is less than 3, then there will be no D subshell. All right. ये अगर पूरा समझ में नहीं आया तो एक बार फिर से वीडियो को बाद में देख लेना. I think there should be no problem in this. Actually, from this the question will come. It can come in the name of quantum numbers. Otherwise, it can come in filling up of electrons. All right. How the electrons fill up. Now we will see what are the principles how the electrons fill up in these orbitals. Okay. So in an orbital, there are maximum of 2 electrons such that their spins are +½ and -½ and sum of the spins is 0. There are maximum 2 electron in S subshell, 6 in P subshell, 10 in D, 14 in F and 18 in G. Okay. How is that? Because here you can see maximum number of electron can be 2. In this it can be 1, 2, 3, 4, 5, 6. So maximum it can be 6. In this similarly 5 into 2 it can be maximum 10. So likewise it will go on increasing. Fine. Now what are the rules for filling of electrons in various orbitals? So the atom is built up by filling electrons in various orbitals according to the following rules. The first rule is Aufbau. Aufbau's principle and N plus L rule. Okay. This Aufbau is a German term which means building up. It is not the name of a scientist. All right. Don't get confused. Aufbau was not a scientist. Aufbau का मतलब होता है building up. ठीक है. This principle states that the electrons are added one by one to the various orbitals in order of their increasing energy, starting with the orbital of lowest energy. The order in which the orbitals are filled with electrons is this. So it is saying orbital with a lower energy will fill up first and the orbital with the higher energy will fill up second. Then what is the next rule? Pauli's exclusion principle. It says according to this principle, no 2 electrons in an atom will have same value of all the 4 quantum numbers. This is what I told. I am an electron, I am unique. So my 4 quantum numbers cannot be the same with any other electron in the atom. No 2 electron in the atom can have same all the 4 quantum numbers. Even if everything is same, at least the S, the spin quantum number will differ. All right. And finally, the Hund's rule of maximum multiplicity. It states that electron pairing in P, D and F orbitals cannot occur until each orbital of a given subshell contains 1 electron each or is at least singly occupied. What does that mean? Here in this P orbital, Hund's rule of maximum multiplicity says that, say there are 5 electrons. So how that 5 electrons will fill up this P orbital? It will be first this, then this, then this, then only it will be this. Okay. This is how the 5 electrons will fill up and not like this. Okay. So this is the way. In case say there are only 3 electrons. So 3 electrons will not be like this. The 3 electrons will be like 1, 2, 3. This is denoted by Hund's rule of maximum multiplicity. Fine. यहाँ तक I think everything is clear. And now this energy level, like say in exam you do not remember the energy level. You do not remember the energy level in the exam. So I will say you one trick. This we used to do in our class 11, 12. You can write the name of the orbitals like this. Like this. And how the electrons will fill up? You can just make up arrows like this. And these arrows will tell you the किसके बाद कौन सा fill up होगा. Here you can see the interesting, like 1s के बाद 2s होगा, that is normal common sense. Then 2p, then 3s, then 3p. After 3p you can see it is 4s and not 3d. It is 4s and not 3d. Why? Because we have read n plus l rule. If you do n plus l of 3d, n है 3, n equal to 3 plus L of D is 2, so it is equal to 5. Whereas for 4s, it is 4 plus 0, so it is 4. Since 4 is less than 5, this is having a lower energy. So 4s will fill up first, then 3d. इसका best example है calcium, right? Ca2 plus. Ca2 plus का electron configuration कर लेते हैं, not 2 plus, sorry. Ca. Calcium atom का electron configuration, let's do it. Calcium is 20, right? So we'll start with 1s2, 2s2, 2p6, 3s2, borrow. Until this, 18 electrons have been done. So according to our common sense, जो हमें rule नहीं पता है, what we will do? We will write this, but this is wrong. It will not be 3d2. In that case, it will be after this, it will be 4s2 because 4s orbital has lower energy than 3d. ठीक है? Is it clear until now? Any problem, any confusion, please ask. Is it clear until now? Yes, Anil, very good. Is it clear until now? If you have any confusion, you can ask me. This is the pattern that I told you. In this way, the electron will be filled up. If you forget it in the exam, you can do it like this and you will get the answer in a moment. And also, these are the orbitals, जो मैंने बोला. Here, any confusion, if you are having any problem, if no problem, please drop a thumbs up or write anything, yes or no, whatever. Please let me know. Whatever I screamed for this long, is it okay? Did you understand that or not? All right, very nice. So I hope you are enjoying the session. Huh? So this is the basic chemistry. ठीक है? अब यहाँ पे we are on the last part of atomic structure, but just before leaving this, we will just discuss one small thing that is called, ठीक है? In the older days, in the older models, when this subshell concept was not there, there was this octet rule. What it used to tell, उसमें तो subshell S, P, DF कुछ नहीं था. In that there were only shells. So in that the concept was maximum number of electrons in that can be 8. ठीक है? This is an old concept and this is the wrong concept. Still I am telling this, why? Because यहाँ से question आया है. What they have given? They have given match the following. In the left hand side, they have given the names of the elements, and in the right hand side, they have given the electron configuration. But the configuration they have not given in the 1s2, 2s2 system. How they have given? They have given like this. ठीक है? All right. So remember, in that the rule was no orbit can have more than 8 electrons. That is an old concept. Abhi ka you know ke maximum can be in the, when n equal to 3, the maximum can be 3n square. So sorry, 2n square. So it will be 2 into 3 into 3 is equal to 18. It can be 18, right? Yes, yes. हाँ, अरे S block that is in periodic table. It is in S block. But why it fills in the S subshell? That is because उसका energy less है. We read the n plus L rule, no? In the n plus L rule, it has a lower energy than the 3D subshell. Because 4 plus 0 is equal to 4. लेकिन 3 plus 2 is equal to 5. है ना? इस वजह से. Fine. So I think you got all of these things. No problem, no issues. So now we have come to de Broglie equation. What is the de Broglie equation? De Broglie equation is basically describes the wave nature of the electron. It basically describes the wave nature of the electron, like we read in the quantum model, wave particle duality. Similarly, de Broglie equation describes the wave nature of the electron. So it says that wavelength associated with a particle of mass m moving with velocity v is given by the relation lambda is equal to h by mv. Tick. In this h is nothing but the Planck's constant, and this is the momentum. So this is the de Broglie's equation, and finally this is the last slide of atomic structure, that is the Heisenberg's uncertainty principle. This also we read in the quantum model of atomic model. This principle states that it is impossible to specify at any given moment both the position and the momentum of an electron. So either you can correctly signify the position or you can correctly determine the momentum, but not both. It is impossible to tell both the momentum and the position at a particular point of time. So mathematically it is represented as del x into del p is greater than equal to h by 4 pi. Here also this h is nothing but Planck's constant. ठीक है? And this del x is the uncertainty in position, this del p is the uncertainty in the momentum. You all know momentum is denoted by p. Fine. So we have ended our atomic structure. Coming to the next, periodic classification of elements. Periodic table, this only has one slide. I have taken the periodic table for you. बाकी यहाँ पे और कुछ समझने का नहीं है. So what type of question can come from this? You all know this is the periodic table. Can anyone tell me who is the father of periodic table? Who for the first time gave the periodic table? This is the modern long form of periodic table, right? Who is the father? Who gave the original actual periodic table? जहाँ से फिर होते होते we have, yes, very good, Neeraj, Mendeleev, yes. Please do not get confused between Mendel and Mendeleev, है ना? Mendel, Gregor Johann Mendel is the father of genetics, whereas Mendeleev is the father of this periodic table. It is Mendeleev, ठीक है? So do not get confused between these two. Fine. Now we know that the periodic table that was given by Mendeleev, it was based on atomic mass. It was based on atomic mass, but the modern long form of periodic table, it is based on atomic number. ठीक है? It is based on atomic number. So according to atomic number, it has been arranged in this matter. अब यहाँ से क्वेश्चन क्या आ सकता है? I don't know whether you can see or not. Below the groups, like see, these horizontal rows this side, these are called the periods, all right, and the vertical grouping is called the groups. ठीक है? So this is one group, this is one group, this is one group, this is one group. Likewise, this is one period, this is one period, this is one period. Likewise, ठीक है? This group 1 is also called what metals? Anyone? अरे जल्दी जल्दी लिखो यार. Periodic table is very easy. We'll just move on. बहुत सारा चीज बाकी है अभी भी यार. Come on. Group 1 elements are called हाँ 18 group 7 period तो बहुत अच्छा है. What are the group 1 elements called? Alkali metals, very good. Group 2 are called alkaline earth metals. These things you should be very thorough. जो यहाँ से question आ सकता है वो बोल रहा हूँ. Group 1 is alkali metals, group 2 is alkaline earth metals. Then this part, these are called the transition metals, right? From 3 to, actually it is from 3 to 11. Huh? याद रखना, zinc is not a transition metal. This can come question in exam. Huh? Zinc is not a transition metal, because transition metal का definition है incompletely filled d orbital. But zinc, if you see the configuration of zinc, it is 3d10 4s2. So its d orbital is completely filled. So zinc is not a transition metal. Please remember, here in this table also you can see whatever is this sky color, those are the transition metals. But these are called post-transition metals. From zinc, it is not transition metal anyone. Yes, very good, very good. Partially filled d orbital है, तभी वो transition metal है. Zinc is not partially filled, it is completely filled. So zinc is not a transition metal. Fine. हो गया. फिर उसके बाद ये सब तो आई थिंक ऑल ऑफ यू हैव रेड ऑलरेडी. दिस नाइट्रोजन का ग्रुप है 15, ऑक्सीजन का ग्रुप है 16. These are called chalcogens, these are called nicogens. These things I am not diving into it. These are called halogens. This group 17 is called halogens. यहाँ पे एक और चीज जो याद रखना है, I don't know whether you can see or not. Below the original number there are some Roman numerals also. ठीक है? 3A, 4A, 5A. This was the group number of Mendeleev. Mendeleev का जो periodic table था, according to that, he classified the elements in different groups and he gave the Roman numerals for those groups. And उसको भी उन्होंने A और B दो group में बांट दिया था. So here you can see A B करके है. So these two comes under group A. These also comes under group A. Whatever is there in the middle, it comes under group B. ठीक है? Like this is 1A, this is 2A, this is 3A, 4A, 5A, 6A, 7A, 8A. Here you can see 3B, 4B, 5B, 6B, like that. ठीक है? इसको भी देख लेना. Chances are very less, but question might come. High chances are these alkali metals, alkaline earth metals, halogens, nicogens, chalcogens. These are extremely important. ठीक है? पता चल गया. Then here you can see post transition metal. हाँ, और दो ये बात है यहाँ पे. One is called transuranic elements. ट्रांस का मतलब है उसके बाद. Transuranic elements है the elements that comes after uranium. Uranium, can you help me find uranium? Where is uranium? Uranium is 92, right? Yes, uranium is 92. After uranium, whichever element is there, these are called transuranic elements. Similarly, after actinide, whatever element is there, these are called transactinide, transactinum. ठीक है? This series starts with La, that is lanthanum. That is why this period is called lanthanides, and this is called actinides. It is starting with actinium, that is why it is actinide. This is starting with lanthanum, that is why this is the lanthanides. ठीक है? यहाँ पे और कुछ बोलने का नहीं है. बाकी these you know, these are the noble gases. This does not react. Now we will come to the sequences. So tell me, across the period, if we move across the period, what will be the effect in atomic radius? Atomic radius छोटा होगा या बड़ा होगा? What will it happen? If we move left to right across the period, what will be the consequence in atomic radius? Decrease. Very nice. अब decrease क्यों होता है? Very easy. Because when we are moving across the period, no new orbitals are added. क्या हो रहा है? Across the period, what? Atomic number is increasing by 1. यहाँ पे 3, atomic number 3, 4, 5, 6, 7 ऐसा हो रहा है, right? So 1 electron is increasing. 1 electron is increasing and 1 proton is increasing. So this electrostatic interaction will make the orbitals squeeze. Since no new orbitals or no new shells are being added, because of higher charge, because of higher attraction force between proton and electron, it will squeeze. That is why across the period, the size will go on decreasing. Because more number of electron proton are there, they will. ठीक है? Across the group, it will be the opposite. Because across the group, when we are going, there is one new addition of orbital. Across the group, for every new element we are going, there is a new addition of orbital. तो मतलब पहले it was like this, then it became this, then it became this. So the radius increases. ठीक है? So radius I will write like this. Across the period decreases, across the group increases. Fine. ऐसे ही question can come for electronegativity. Electronegativity का भी same है. Electronegativity is also the same. Electronegativity across the period, it will decrease, across the group, it will increase. Similarly, ionic potential also, ionic charge by radius, that is also having the same fate. ठीक है, ionic potential का formula है IP is equal to charge by radius. ठीक है, so all these properties, I know all of you know that, there is nothing new. So question might come like this: across the period, what happens? Across the group, what happens? And name of all these groups. You should be very thorough. Any confusion in periodic table? If not, please put a thumbs up, and we will move on to our next part of the syllabus. Any confusion? Anything you want to ask? Anything? If not, please put a thumbs up, or please write something, whatever, so that I know I am not just screaming in vain. At least whoever is there, please write something. Shreyoshi, okay. Anyone else? Fine. So, I told you, we will be moving exactly through the syllabus. We will not do anything extra. So, this has been taken exactly from your syllabus. Fine. From this first thing, this element and compound, I don't think इसको पढ़ाने का कोई भी जरूरत है, or you need to know anything about this. So, we will not touch this. Still, just one sentence. Element, you all know, everything is element, whatever was there in the periodic table. Oxygen, nitrogen, boron, singularly, carbon, everything is an element. And compound is, thank you ma'am, thank you Shubhra ma'am. And compound is when two or more elements combine, that forms a compound. So, calcium is an element, but calcium carbonate is a compound. ठीक है? Calcium is an element, calcium hydroxide is a compound. Carbon is an element, carbon dioxide is a compound. ठीक है? यहाँ पे तो I don't think anyone has any problem. So, element and compound is done. Element and compound में और कुछ I don't understand also यहाँ से क्या question आ सकता है. यहाँ से इसके अलावा तो कुछ है नहीं. Why they have put element and compound, I have no idea. But इसके बाद जो है, these are the actual OGs. Let's move on. So the common ion effect. What is the common ion effect? This has been specifically mentioned in the syllabus. So we will specifically read this. The common ion effect refers to the suppression of the degree of dissociation of a weak electrolyte, suppression of the degree of dissociation of a weak electrolyte, or the reduction in solubility of a sparingly soluble salt upon the addition of a strong electrolyte that shares a common ion with the existing equilibrium system. ठीक है, क्लियर हुआ? नहीं हुआ तो हम फिर से बात करेंगे, डोंट वरी. It is governed by Le Chatelier's principle. This is very important, इसको याद रखना. And the law of mass action given by Goldberg and Waag. These are the two laws that govern this common ion effect. When the concentration of one of the products is in reversible reaction is whatever. We don't need this because we will understand this through example. ठीक है? Let us take an example of a sparingly soluble salt. Sparingly soluble salt क्या है? Calcium sulfate. ठीक है? Then what it is telling? How will this calcium sulfate dissociate? This calcium sulfate will dissociate as Ca2 plus aqueous plus SO4 2 minus aqueous. All right? This is the thing. ऐसे ये dissociate हो रहा है. Now this is a sparingly soluble salt. लिख देता हूँ. This is sparingly soluble. Now what it is telling? In the presence of a strong electrolyte or in the presence of a highly soluble salt, say CaCl2. CaCl2 क्या कर रहा है? CaCl2 will also, it will dissociate in the same manner, right? Aqueous. Now what is this common ion effect? The common ion effect is nothing but if these two salts are present together, this will dissociate in this manner, this will dissociate in this manner. But since this is pairingly soluble and this is highly soluble, this calcium in the system will influence the dissociation of this calcium in the system. That is why this reaction, we all know the equilibrium principle, right? This is the reactant, this is the product. So if the reactant is increasing, the equilibrium will move that side, the reaction will move that side. If the reactant is increasing, if the product is increasing, it will move towards the reactant side. So here this Ca2 plus is being supplied by this CaCl2 Ca2 plus. This will result in shifting of the reaction towards this side. It will shift the reaction towards the backward side. So जितना भी dissociation हो रहा था, अब that dissociation, that degree of dissociation will be less. That is called the common ion effect. Common ion effect. This calcium is the common ion. You can see it is here also, it is here also. In the sparingly soluble salt, in the highly soluble salt, calcium is the common ion. This calcium of the highly soluble salt, it is influencing this calcium of the sparingly soluble salt, and it is forcing this reaction to move backward, resulting in less dissociation of this calcium sulfate. That is called a common ion effect, right? Understood? If understood, please put a yes. Yes or a thumbs up, whatever you want. So you can read here also. Now if you read, you can easily understand what they are trying to say. Common ion effect refers to the suppression of the degree of dissociation of a weak electrolyte or reduction in solubility of a sparingly soluble salt upon the addition of a strong electrolyte that shares a common ion with the existing equilibrium system. This common ion can be both cation and anion. It is governed by La Chatelier principle that just we read here, because this principle of equilibrium is nothing but it is La Chatelier principle. It says that whenever there is an external disturbance to an equilibrium, the equilibrium changes in such a way so that the equilibrium is maintained. So यहाँ पे external disturbance है ये जाके इसको बढ़ा रहा है, so the equilibrium shift towards that side to keep the equilibrium in the constant condition. That is why it is the La Chatelier principle and it is also the law of mass action. ठीक है? So I think common ion effect is also done fine. Now we have solubility product में बाद में आते हैं, because solubility product I have not brought any material. I will completely write it and tell you. ठीक है? Then come to acid and bases. In this acid and bases, these three concepts are very important because I have seen many questions from these three concepts. That's why we have put this slide here for you. Only these three concepts is enough. So what is Arrhenius concept? Arrhenius concept says that acids are those substances which produces H+. ठीक है? H+ has the only cation that is being dissociated. So HX, H+ plus X minus. Bases are those which produces OH minus as the only anion. ठीक है? According to Arrhenius, acids produce H+ as the only cation and bases produce OH minus as the only anion. Khatam. Then the Bronsted-Lowry concept, what it says? It says acid is a substance that is capable of donating a hydrogen ion. It is based on the concept of proton. So acid donates a proton, whereas bases are substances capable of accepting a proton. So bases are nothing but they will take this proton. That is the Bronsted-Lowry concept. इसमें confuse मत होना. There is high chance of getting confused between these two. Please be very, very careful. ठीक है? Then finally Lewis concept. You all know it is based on electron concept. It says, according to this theory, acid is a species that can accept electron pair, whereas a base can donate electron pair. So this is based on electron and not on proton. It says acid can accept electron pair, whereas base is something which can donate this electron pair. ठीक है? बढ़िया? I think we are done. Now, this is the third portion of the syllabus, that is salt hydrolysis. What is the salt hydrolysis? Hydrolysis, I know you all have read in weathering. Yes, in the weathering, in the pedology you have read what is hydrolysis. Hydrolysis means lysis of water. वाटर को तोड़ना है, फिर वाटर को तोड़ने के बाद उसमें जो H+ और OH- है उसके साथ रिएक्शन करना है. That is hydrolysis in simple terms, है ना? So what is salt hydrolysis? When a salt is dissolved in water, it dissociates completely into its constituent cations and anions. बहुत अच्छी बात है. Hydrolysis occurs when these dissolved ions react with water molecules to alter the concentration of H plus or OH minus, thereby shifting the pH of the aqueous solution away from the neutrality. ठीक है? A general rule dictates that ion derived from weak acid or weak bases will react with water, whereas ion from strong acid or strong base function as a spectator ion and will remain hydrated without altering the water equilibrium. ठीक है? Ions derived from weak acid and weak base, they will only participate in hydrolysis reaction, whereas ion from strong acid and strong base are called spectator ions and they do not participate in the hydrolyzing reaction. ठीक है? अब इसको easily समझाने के लिए I have got you this table. इस टेबल को एक बार देख लेना. It is more than enough. There can be no question in JRF जो इस टेबल के बाहर से आए. ठीक है? So strong acid plus strong base, I already told, it will not participate in hydrolysis. ठीक है? So the solution pH will be at 7. And what is the example? Potassium chloride. Because why is it strong acid and strong base? Because here this potassium has come from KOH. KOH is a very strong base, you know, and this NaCl has come from HCl. So this is a strong acid, this is a strong base, strong acid plus strong base, so it has no hydrolyzing ion. Fine. Then moving on, weak acid plus strong base. In this, the hydrolyzing ion is anion. The pH will be alkaline, more than 7, and here it is sodium acetate. How? Again the same. Sodium acetate comes from acetic acid, which is a weak acid, yes, and this Na comes from NaOH, which is a strong base. तो हमने क्या पढ़ा? जो आयन strong base या strong acid से आता है, that acts as a spectator ion. So this Na will not participate. This Na will not participate. Who will participate? This CH3COO. So once this CH3COONA is put in a solution, it will dissociate as CH3CO minus plus Na plus. ठीक है? This is the dissociation. This CH3CO minus, this will participate in hydrolysis reaction and it will form undissociated acetic acid plus OH minus. It will supply this OH minus and it will shift the pH from neutrality and it will make the pH alkaline. Is that clear? Is that clear? I think it is very clear. ठीक है? Similarly, strong acid plus weak base, उसका एकदम उल्टा, that is cation. Acidic pH less than 7. Here ammonium sulfate. Again, ammonium sulfate में ammonium जो आया है, this ammonium has come from NH4OH, ammonium hydroxide, that is a weak base. Then this SO4 has come from H2SO4. You all know that is a strong acid, very strong acid. Then finally, weak acid plus weak base, both can participate. It depends on the dissociation constant of the acid and the base. And this example is CH3CONH4. In this, which ion will participate? That will be decided by this Ka and Kb. ठीक है? इस टेबल को याद कर लेना. It will be more than enough for any question that comes from salt hydrolysis. ठीक है? याद करने का भी कुछ नहीं है. This is a very simple table. You can just read and understand it. फिर इसमें याद करने लायक कुछ नहीं. You can simply understand everything. ठीक है? Any problem? Anyone? Any problem if you have? We are completing one part. इस part में अगर कोई problem है तो बताओ. Tell me. If no problem, you can write yes or okay or put a thumbs up, whatever you want, just put. Okay, is everything okay? Confidence आ रहा है chemistry से, हाँ? It's clear, very nice. ठीक है, बहुत अच्छी बात है. तो फिर chemistry clear है मतलब तो very nice, हाँ? Moving on. Next is buffer solutions. This is also a very important topic, है ना? What is a buffer solution? What is a buffer solution? I think all of you know what is a buffer solution. A buffer solution is a solution that resists the change in pH. ठीक है? Buffer solution resists the change in pH. अब ये कैसे करता है? उसका mechanism देखना है. ठीक है? Buffer type acidic buffer. What is the composition of a buffer? Can you tell me what is the composition of a buffer? How a buffer solution is made? A buffer solution is made by, here you can see, there will be a weak acid or a weak base and its conjugate salt. That is how a buffer is made. How? I will make it very clear for you. We will take this example, CH3COH and CH3CON. So, how a buffer solution is made? First, we will take a weak acid. We are discussing about acidic buffer. Basic buffer में भी same है, कुछ अलग नहीं है. So, we will take a weak acid. We have to take a weak acid and a salt of this weak acid. ठीक है? This whole solution acts as a buffer solution. ठीक है? This whole solution acts as a buffer solution. अब question है how it acts as a buffer solution. See, एक बात हमेशा याद रखना, when if this is the acid, then can anyone tell me what is its conjugate base? Can anyone tell me what is the conjugate base of HCl? What is the conjugate base of HCl? Very nice. So हमेशा याद रखना, if it is a strong acid, then its conjugate base is always weak. ठीक है? If it is a strong acid, then its conjugate base is always weak. इसका मतलब क्या है? This will very easily dissociate because इसको तो H plus छोड़ना है ना. HCl जब भी डालोगे, it will become H plus Cl minus. But this Cl minus will not take H plus that easily because इसको तो छोड़ना है ना. It is a strong acid. So this is a weak base because it cannot accept H plus that easily. ठीक है? Similarly, in case of a weak acid, in case of a weak acid, the conjugate base is very strong. ये क्यों है? Weak acid का मतलब क्या है? इसको dissociation में उतना मन नहीं है. He does not want to dissociate. So when it is dissociated, this becomes a very strong base because इसके पास जब भी H plus आएगा, ये पकड़ के इसको फिर से CH3COOH बना देगा. ठीक है? This is the concept of conjugate base and acid. Fine. Now this concept is only exploited for making a buffer solution. ठीक है? So in case of an acidic buffer, this will form the buffer solution. अब इसमें अगर ज़्यादा H plus if you put then this CH3COO minus will react with this H plus and form CH3COH, thereby resisting the drop in pH. ठीक है? Is that clear? Anyone? Is it clear? Similarly, in this also the same. In this, if you add OH minus, this will supply the NH4 plus, which will react with this OH minus and it will form NH4OH. So it will resist the increase in pH. ठीक है? Is it clear? Please write yes or no. Anything, please. Is that fine? I think it should be fine. पता तो I think चल जाना चाहिए, है? Yes, very nice. Thank you so much. यहाँ पे just for one question purpose, ये यहाँ पे लिखा हुआ है. This can be a direct question in your JRF. That's why I have put this line. The precise pH of a buffer system is mathematically derived from the equilibrium constant and the relative molar concentrations. This reaction is defined by Henderson-Hasselbalch. ठीक है? ये नाम याद रखना है. Buffer solution का concentration उसका pH क्या होगा, दैट इज डिफाइंड बाय हेंडरसन हैसेलबैक इक्वेशन। अब इस इक्वेशन में भी हम घुस सकते थे, बट सैडली वी डू नॉट हैव दैट टाइम। ठीक है, आई थिंक इतना काफी है, इसके ऊपर जेआरएफ लेवल में यू डू नॉट एक्सपेक्ट, नहीं आएगा। ठीक है, नाउ वी हैव कम टू स्टैंडर्ड बाकी क्लासिफिकेशन। हाँ, वेरी नाइस, वी आर ऑलमोस्ट ऑन द वर्ज ऑफ एंडिंग आवर बेसिक केमिस्ट्री। ठीक है, सो we have come to equivalent weight. What is equivalent weight? ठीक, I have written like a story for you so that if you read you will understand अपने आप से. While molecular weight tells you how heavy a molecule is, equivalent weight tells you how much of that mass is required to supply a single unit of chemical reactivity. So molecular weight deals with the weight, it deals with the heaviness of the molecule, whereas equivalent weight it deals with the reactivity of the molecule. Equivalent का मतलब है 1 unit reactivity में कितना molecule चाहिए. See, supply a single unit of chemical reactivity. हमेशा याद रखना, in this whole universe, wherever there is any reaction happening, a reaction always happens between two equivalents. दोनों कंपाउंड इन इक्विवेलेंट प्रोपोर्शन ओनली रिएक्ट्स. ऐसा नहीं है कि मोल आल्सो सेम, बिकॉज वी ऑल नो द सिंपलेस्ट रिएक्शन लेते हैं N2 plus H2, हाँ, NH3. Here you can see 1 mole of N2 is reacting with 3 mole of H2 to form 2 NH3. So molecular weight or mole might not be the same, but हमेशा याद रखना, any reaction that takes place in this universe, it happens equivalent के साथ equivalent का reaction होता है. There is no other way. ठीक है? Historically, equivalent weight was defined as the mass of a substance that reacts with or displaces 1 gram of hydrogen, 8 gram of oxygen, or 35.5 gram of chlorine. This was the historical definition. ठीक है? 1 gram of hydrogen, 8 gram of oxygen, 35.5 gram of chlorine के साथ जितना मास रिएक्ट करता है, that is the equivalent weight. But now in modern thermodynamic and stoichiometric terms, equivalent weight is defined on the basis of these 3 criteria. ठीक है, उसका पहला criteria है supplies or reacts with 1 mole of hydrogen ion in an acid base neutralization, supplies or reacts with 1 mole of electron in a redox reaction, in case of redox reaction electron, in case of acid base reaction hydrogen, and finally carries 1 mole of positive or negative charge in a salt precipitation or dissolution. ठीक है, so in case of a salt precipitation reaction it will carry 1 mole of positive or negative charge. जितना mass carry करेगा, that is the equivalent weight. I think you are done with equivalent weight. Good evening bhai, good evening. अच्छा, हाँ, good evening ma'am. ठीक है, so the equivalent weight here you can see the formula is definitely molecular weight or atomic weight divided by the n factor, right? Molecular weight or the atomic weight divided by the n factor. In this, again I have given a table for you so that it is very easy for you to revise before JRF. In case of acid, what is the definition of n factor? That is the basicity. I think all of you know what is the basicity of an acid and acidity of a base, huh? So it is the number of replaceable H plus ion per molecule, that is the basicity, and that is the n factor. So here I have given one example for you. In case of H2SO4, molecular weight is 98, n factor is 2. Here you can see replaceable hydrogen atom is 2. So equivalent weight will be 98 by 2 is equal to 49. ठीक है? Is it fine? Molecular weight is 98, equivalent weight is 49. Similarly, in case of base, the n factor is acidity, number of replaceable OH minus. So in case of calcium hydroxide, you can see 74 by 2, that is 37. In case of salt, total magnitude of positive or negative charge, calcium carbonate, it dissociates into Ca2 plus and CO32 minus. So both have 2, so n factor is 2, it is 50. The equivalent is 50. For ions, the valency is the n factor, whereas for NH4 plus, you can see it is the 18. Is that clear? Any confusion? I don't think there is any gunjaish of any confusion. Is it okay or you need any other explanation? Can you please write? Is it fine? Is it all right? All right, very nice. Thank you so much. This slide is specifically for questions because यहाँ पे थोड़ा सा याद रखना है, ठीक है? So that is why I have added this slide. This is specifically for questions. Equivalent weight of KMnO4. These two are like the favorite compounds of all the examiners. Potassium dichromate K2Cr2O7 and potassium permanganate KMnO4. इन दोनों का equivalent weight का थोड़ा सा problem है. That is why it has been listed here. In acid medium, it reacts as MnO4 minus to Mn2 plus. MnO4 minus से Mn2 plus, change in oxidation state is 7 minus 2 is equal to 5. 7 कैसे हुआ? 7 ऐसे हुआ. Here 4O is there, that is minus 8. And the overall charge is minus 1. So minus 8 plus 1 is equal to, 4O is equal to minus 8 and overall charge is minus 1. So plus x minus 8 equal to minus 1. So plus x will be 8 minus 1 equal to 7. So here Mn का oxidation number है plus 7. From plus 7 it is going to plus 2. So the change is 5. That is why molecular weight in acid medium it will be 158 by 5, that is 31.6. Very important. Especially this figure is very important because this 31.6 always it comes in exam. I have seen many times. Please remember this. In case of alkaline medium, the change is only 1. You see, the change is only 1. So in that case, the equivalent weight will be 158. In neutral medium, the change in oxidation number is 3. In that case, it will be 52.6. So I would suggest you to make a table and remember this, but remember this is very important. Similarly, in case of K2Cr2O7 in acidic medium, the change in oxidation number is 6. Okay? The change in oxidation state is 6, so the N factor is 6, so it will be 294 by 6 is equal to 49. This is also very important. Fine? I think fine ही है. Now we have come to standard solution. What is a standard solution? A standard solution is a highly characterized reference solution containing a precisely known concentration of a specific solute. Standard solution का मतलब है उसका concentration हमें already पता है. We already know what is the concentration of that. ठीक है? That is why it is called a standard solution. In analytical chemistry, these solutions serve as the definitive baseline for quantitative analysis, most notably in volumetric titration. So, standard solution is nothing but a reference solution. In our life also, we have seen many standard students with whom our parents or our teachers always compare us. This guy is a standard student, be like him. Similarly, standard solution is used for that. That is a reference. So, usko dekh ke we will try to measure the concentration of unknown solutions. Unknown solution का concentration हमें पता नहीं है, standard solution का concentration हमें पता है. By comparing, we will try to find out. ठीक है? That is a standard solution. In this, अब इसमें से question क्या आता है? Question आता है classification of standard. Very important. Standard solutions are categorically divided into two primary typologies based on these factors. So, primary standard and secondary standard. These are very important. ठीक है? So, what is a primary standard? It is a substance of extreme purity and stability that can be directly weighed and diluted to form a standard solution. ठीक है? Whereas secondary standard, its concentration cannot be determined by direct weighing, requiring standardizing against a primary standard first. तो प्राइमरी स्टैंडर्ड क्या है? प्राइमरी स्टैंडर्ड आर दोज कंपाउंड्स जिसको हम डायरेक्टली बैलेंस में डालेंगे, बैलेंस से उसका वेट करेंगे, उसको सॉल्यूशन बना देंगे, जो कॉन्सेंट्रेशन आया दैट इज द स्टैंडर्ड सॉल्यूशन. इन केस ऑफ सेकेंडरी स्टैंडर्ड वी कैन नॉट डू दैट. डायरेक्टली वे करके अगर उसको डालेंगे, उसका सॉल्यूशन बनाएंगे, दैट सॉल्यूशन विल गिव एरोनियस कॉन्सेंट्रेशन. उसमें क्या करना पड़ेगा? सेकेंडरी स्टैंडर्ड के लिए सेकेंडरी स्टैंडर्ड सॉल्यूशन बना के उसको प्राइमरी स्टैंडर्ड के साथ वी हैव टू फर्स्ट कैलिब्रेट इट, देन ओनली वी कैन यूज इट. ठीक है? ये हुआ दोनों का डेफिनेशन। अब ऐसा क्यों है? की प्रॉपर्टीज ऑफ प्राइमरी स्टैंडर्ड आर हाई प्योरिटी, इट शुड बी वेरी हाईली प्योर बिकॉज हम डायरेक्टली यूज कर रहे हैं, सो इट शुड बी वेरी हाई प्योरिटी, हाईली स्टेबल इन एटमॉस्फेरिक कंडीशन, नॉन हाइग्रोस्कोपिक इज वेरी 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 इंपॉर्टेंट, and generally possesses a high equivalent weight to minimize fractional weighing errors. जितना भी तरीके से हम एरर को कम कर सकते हैं फॉर मेकिंग ए स्टैंडर्ड सॉल्यूशन, प्राइमरी स्टैंडर्ड शुड हैव ऑल दोज प्रॉपर्टीज. In case of secondary standard, it have lower purity, highly reactive, often very hygroscopic, absorb moisture from the air or this. इसमें सोचो NaOH. Whoever has worked at least one day in the laboratory of soil science has seen NaOH crystal, है ना? NaOH का जो pellets आता है, beads of NaOH. All of you have seen that. You keep it open in the air for say 5 minutes. उसके बाद आके देखना वो NaOH, इवन इफ इट इज अ न्यू बॉटल, एकदम न्यू केमिकल की बॉटल से निकाल के उसको 5 मिनट के लिए बाहर छोड़ दो, देखना इट हैज एब्सॉर्ब लॉट्स ऑफ मॉइस्चर एंड इट हैज बिकम हाइग्रोस्कोपिक. अगर उसने मॉइस्चर एब्सॉर्ब कर ही लिया, so now if you put that NaOH and make a solution of say 1 normal, is that actually 1 normal? Is that actually 1 molar? It is not. That is the problem with secondary standard. So hygroscopicity is a major thing. Primary standard should never be hygroscopic. कितना देर भी उसको बाहर रख लो, it should never absorb moisture from the atmosphere. But secondary standard जो है, it does. So coming to the examples, all these examples are taken from ISSS का soil analysis book. So अगर question आया, तो you can expect these examples only directly. So इसके बाहर जाने का ज़्यादा ज़रूरत नहीं है. These are I think enough. So examples of primary standard include sodium carbonate. ठीक है, याद रखना it is sodium carbonate, bicarbonate नहीं, sodium carbonate only is primary standard because in my SRF it came, they gave sodium bicarbonate also. ठीक है, then oxalic acid, then potassium hydrogen phthalate. These are primary standard. Secondary standard का example all of you know, NaOH, HCl, H2SO4, HNO3, whatever we use normally in lab, these are the secondary standards. Fine, very nice. Now we have come to IUPAC nomenclature. This also we had to include because it is in the syllabus and यहाँ से question आते हैं. ठीक है, यहाँ से question आते हैं. So again we will just read one table. Principal functional groups in order of decreasing priority. ठीक है, decreasing priority का मतलब है till now I have not seen any question in JRF where they have given mixed functional group. मतलब एक ही compound में alcohol भी है, कार्बोक्सिलिक एसिड भी है, एल्डिहाइड भी है, ऐसा कंपाउंड आज तक दिया नहीं है. व्हाट इफ दे गिव्स? कोई श्योरिटी तो नहीं है. आफ्टर दिस लीक एंड ऑल दे माइट रेज द स्टैंडर्ड ऑफ द क्वेश्चन, यू नेवर नो. ठीक है, सो इन दैट केस व्हेन देयर आर मल्टीपल फंक्शनल ग्रुप्स देयर शुड बी ए ऑर्डर ऑफ प्रायोरिटी. ठीक है ना, बिकॉज यू नो इन IUPAC nomenclature you have to number the carbons in the chain, you have to number the carbons. अब वो नंबरिंग हम कहां से स्टार्ट करें? Should we start it from left? Should we start it from right? So the basic thumb rule is you should start it from the functional group. Or if the functional group is not at the terminal end, it is in the middle, then you should start numbering in such a way that that functional group gets the lowest possible number. Like in case of ketone. In case of ketone, keto group cannot be in the end of a chain. So you have to start numbering in such a way so that it gets the lowest possible number. Like that. अब एक फंक्शनल ग्रुप कंपाउंड में है, फिर तो नंबरिंग इज वेरी इजी, वी कैन डू दैट. बट व्हाट इफ देयर इज कीटोन आल्सो, देयर इज कार्बोक्सिलिक एसिड आल्सो, देयर इज अल्कोहल आल्सो. इन दैट केस यू हैव टू फॉलो दिस प्रायोरिटी सीक्वेंस. ठीक है, so that is why I have given this table in decreasing priority, so that if you take a screenshot or if you read this priority series once, you will know. So principal functional groups, carboxylic acid comes number 1 in priority. इसका structure तो सबको पता है. If it is used as a substituent, जिसका possibility नहीं है, still it will be carboxy. And if it is the principal functional group, it will be oic acid. In case of ester, it will be OAT. In case of amide, it will be amide. In case of nitrile, it will be nitrile. In case of alcohol, it will be ol. Ketone, on. Amine, amine. Alkene, in. Alkyne, alkyne. And for aldehyde, it will be al. I think all of you know this. There is nothing more. You can see the structure of the groups here also. ठीक है? And this one I have specifically taken for you. because if benzene ring acts as a substituent, then the prefix used is phenyl. ये मैं अलग से इसलिए मेंशन किया हूँ because do not get confused with phenol. ठीक है? Phenol and phenyl is not the same. What is a phenol? Phenol is a benzene ring that is having a OH. This is a phenol. ठीक है? And if benzene ring acts as a substituent, substituent का मतलब क्या है? Say one compound is going like this and there is a benzene ring. Then again it is going on, then it is going like this, then it is going on like this. In this case, the prefix that will be used is phenyl. ठीक है? समझ में आया? There is another confusing term that is called benzyl. That is also different. Benzyl and phenyl is not the same. Benzyl का मतलब है benzene plus there will be one CH2. Then there will be this compound, whatever compound that is. This in total is benzyl. Only benzene ring, that is phenyl, and this is phenol. ठीक है? समझ में आया? If yes, please write हाँ, whatever, yes, है, anything, whichever language you want to write, please write yes, no, yes. Don't worry, we will do this IUPAC nomenclature का question है last में, in that we will do. उसमें भी अगर कोई प्रॉब्लम आ रहा है तो we will do that, don't worry. ये बताओ कि समझ में आया कि नहीं? IUPAC nomenclature में ज्यादा कुछ तो नहीं है. You just have to count the number of carbons. You just have to count the number of carbons. Then according to that carbon, I think that table हमने यहाँ पे नहीं दिया, but I think all of you know that, right? One carbon, I think all of you know this, right? This table ये तो अलग से देने का जरूरत है क्या? This you know. One carbon is there, then it is meth. So CH4 is methane. Because since there is C and all are single bonds, H, H, H. So it is N, and meth because there is only one carbon. So in case of eth, this is a ethane, right? If the compound was like this is a ethene. If it was like this, it is a ethyne. I think you know this, right? और इसमें भी जाने का जरूरत है अंदर. Tell me, is it fine? These things you know or you don't? Similarly, it will go on like this: butane, butene, butine, pentane, pentene, pentine, propane. Then अगर प्रोपेन के साथ एक अल्कोहल आ गया तो प्रोपानॉल. अगर प्रोपेन के साथ एक एल्डिहाइड आ गया प्रोपानेल, है ना? These things are clear. ये सब तो जितना क्वेश्चन आया है वो हम देखेंगे. But these things I think you all know. So you have to count the number of chains, count the number of carbons, count the number of carbons, starting from the functional group, and then you have to see the functional group. Based on that, you have to name that compound. If it is an alcohol, it will be propanol, it will be butanol. जिस position में alcohol है, that will be butan-1-ol, that will be butan-2-ol. ठीक है? And in numbering there is another thing. ठीक है? मान लो एक ही ग्रुप है, से in this, say the alcohol is in this. I told you have to start numbering from the functional group, but यहाँ पे you cannot start from the middle of a chain, right? Because you will start from here, फिर इधर जाओगे कि इधर जाओगे. In that also, that law will be valid. You have to number in such a way that it gets the lowest possible number. So हम यहाँ से count करेंगे 1, 2, 3, 4. So it is a but. So this is the actual IUPAC nomenclature butane to all. ठीक है? If this OH was here, if it was the compound, then it would have been all three of this is the same thing. Okay, it will be butan 1 all because it is in the first carbon, then butanol because butanol agar hum likh rahe, if we are not specifying which carbon, then we will assume it is with the first carbon only. And N-butyl alcohol, this was used in older literature jahan pe N means at the end of the chain, at the end, that is called N. So N-butyl alcohol, so it is a butyl alcohol, uske last mein hai, so that is a N-butyl alcohol. So is it clear until this? Is it clear until this? Please tell me. So यहाँ पे जो था, I think we have completed all the syllabus. बाकी if it is clear, please write. Hydrolysis of salt we have done, buffer solution we have done. इसके साथ साथ भी we have done other things also. So we have done everything except this solubility product. ठीक है? Until now, is it clear? Please let me know. मुझे थोड़ा बताइए आप लोग. If you have any question, any doubt regarding anything, कहीं पे भी कुछ भी doubt है, you can ask. If not, then you please write, put a thumbs up or put anything, whatever you want. Solubility product पढ़ेंगे, फिर हम बायोमोलिकुल्स में जाएंगे और खत्म, है ना? Anyone? Is anyone there or not? कोई बात नहीं. There might be some glitch also. I don't know. So, solubility product. Let us understand what is a solubility product. Clear, sir. Thank you. What is a solubility product? What is solubility product? Anyone? Can anyone tell me what is a solubility product? Still no answer. खैर कोई नहीं. Solubility product is for sparingly soluble salt. Sparingly soluble salt में क्या है? Let us take the example of a sparingly soluble salt. से हम JRF वाला example लेंगे, PbF2. ठीक है? PbF2, that is a solid. PbF2, that is a solid. That will dissociate as Pb2 plus aqueous plus 2F minus aqueous. ठीक है? This is how it will dissociate. ठीक? Then we know, according to the laws of chemical equilibrium, at equilibrium, at a particular temperature, the equilibrium constant, it is given by the product of the reactants raised to the power of their stoichiometric coefficient divided by the concentration of the reactant. So it is the ratio of the product of the products divided by the concentration of the reactant. In this case, this is a solid, and we know for solid the concentration we have to take it as unity. Solid का concentration हम measure नहीं कर सकते. So this we will take as 1. In case of any solubility product, जहाँ पे भी हम उसको determine करेंगे, the denominator will be 1. So the new value of KSP will be PB2 plus into F minus to the power 2. So in other words, the definition of solubility product is, it is the product of the concentration of the products in aqueous solution of a sparingly soluble salt with their stoichiometric coefficients raised to their power. ठीक है, ये हुआ हमारा solubility product. It is nothing but it is normal chemical equilibrium constant, because it is at equilibrium and it is at a particular temperature. The only thing that is making it unique is it is for a sparingly soluble salt, and since the left hand side, that is the reactant side, is having solid, that is why this denominator will be 1 and only the numerator term will remain. ठीक है, that is KSP. So I think we have understood what is KSP. We will take, say, another example. We will take CaSO4. The KSP of this will be ठीक है? Is that clear? Is it clear? That is the KSP. This KSP is the solubility product. This is a constant, right? This KSP is a solubility product. This is a constant. Fine? Is it fine? Now, यहाँ से question क्या आता है? ठीक है? Question क्या आता है? We will again go to that example of PbF2. PbF2 का KSP has been given. Some KSP has been given. Say KSP दिया है 3.2 into 10 to the power minus 8. I remember the value. ठीक है? This is the KSP and they are asking what is the solubility. What is the solubility? Solubility and solubility product. So solubility का मतलब क्या है? Solubility का मतलब है they are asking the concentration of these terms, है ना? That is what solubility is, because solubility का product is solubility product. So they are asking what are the concentration of these terms. तो इसको कैसे करना है? Very simple. In this, what we will do? We will assume the solubility of this ion as S. So this will be 2S. ठीक है? Because हमें पता नहीं है S निकालना है. So KSP will be equal to S into 2S का whole square. So it will be S into 4S square. So it will be 4S cube. All right? From this equation, this value is already given. So you can find out the value of S. That is how you will get this. Is it clear? Please let me know. Is it clear? यहाँ से सारा clear है. यहाँ पे और 2-3 चीजें हैं, वो भी मैं बता दूंगा. But until now, is it clear? Please tell me. Please let me know. Is it clear? Any doubt? Anything you can ask freely. अभी सामने एग्जाम है कुछ दिन में, है ना? And this is the last marathon, so you will not get a chance to ask again. आज जो पूछना है पूछ लो भाई. So now there is another term that is called Q, that is the reaction quotient. Now what is this reaction quotient? This reaction quotient is nothing but this term only. This term at equilibrium is called KSP, solubility product. But at any point of time, at any instantaneous point of time, this term is called the reaction quotient. So फिर से हम यहाँ पे एग्जाम्पल लेंगे. So PbF2, ठीक है. So the reaction quotient will be at any point of time of the reaction, but only at equilibrium, only and only at equilibrium it will be known as KSP. ठीक है. That is also the same reaction, but only at equilibrium. Now what is equilibrium? Equilibrium is when the rate of forward reaction is equal to the rate of backward reaction. मतलब from this solid जितना dissociation हो रहा है उतना ही it is returning back, उतना ही these ions are again associating with themselves and forming this. So at equilibrium the rate of this reaction is equal to the rate of this reaction, and that is the point of equilibrium. Point of equilibrium में इस दोनों का concentration का जो product है that is called KSP. लेकिन when the equilibrium has not reached before equilibrium, तब at any point of time, instantaneous point of time, that is called the reaction quotient. ठीक है. अब ये मैं क्यों बोला? Because there are three conditions. At any time, if reaction quotient is greater than the solubility product, Q equal to solubility product and Q less than solubility product. Can anyone tell me what will be these fill in the blanks I expect from you? In case the reaction quotient is more than the solubility product, there will be very nice, Shreyoshi, very nice, brilliant. And then for this, all right, this is very, very, very important from question point of view. ठीक है. अब इसमें भी कुछ rocket science नहीं है, because I told you Q and KSP are the same. Q and KSP are the same, only this is at equilibrium. So इक्विलिब्रियम में जितना कॉन्सेंट्रेशन आयंस का होना चाहिए था उससे ज्यादा अगर Q का वैल्यू हो गया है, सो इसका मतलब है बैकवर्ड रिएक्शन और नहीं होगा. सो वो जाके प्रेसिपिटेट हो गया. इट हैज प्रेसिपिटेटेड, इट कैन नॉट डू एनी रिएक्शन एनीमोर. इफ इट इज इक्वल, दैट मीन्स इट इज एट इक्विलिब्रियम, इट मीन्स द सॉल्यूशन इज सैचुरेटेड. जितना जा रहा है आगे उतना आ रहा है पीछे. इट इज एट परफेक्ट इक्विलिब्रियम. इन केस Q इज लेसर देन KSP, Q इज लेसर देन KSP का मतलब है, Q इज लेसर देन KSP का मतलब है इसका जितना कॉन्सेंट्रेशन एक्चुअल में होना चाहिए उतना अभी तक हुआ नहीं है, उतना अभी तक हुआ नहीं है. सो इट विल मूव टुवर्ड्स द राइट एंड दिस सॉलिड स्पेयरिंगली सॉल्युबल सॉल्ट विल बी मोर सॉल्युबल. ठीक है. आई थिंक सॉल्युबिलिटी प्रोडक्ट से सारा कुछ हमने समझ लिया. इफ देयर इज एनी डाउट, एनीथिंग यू कैन आस्क. इफ नॉट, you can write a thumbs up, put a thumbs up or write an yes, and we will move on to biomolecules. Basic chemistry we have completed. We have completed in 1 hour and 50 minutes. I think that is fair enough because lots of things were conceptual and concept समझाना पड़ता है. तो let me know. Basic chemistry में कुछ अगर कहीं पे any problem is there, you can let me know. Anything, if you have any problem, you can let me know. Or shall we go on to biomolecules? That you tell me. Then we will move on to biomolecules, है ना? So this also we have completed, huh? Everything we have completed. So equilibrium concentration क्या है, ionic equilibrium क्या है, उसी हिसाब से, है ना? वो जो अगर याद नहीं रह रहा है तो you can write like this. This is the actual concept of chemical equilibrium. This is called the equilibrium constant. वहां से आता है solubility product. In this part gets cancelled. ठीक है? And I think ये तो सबको पता है. This is the stoichiometric coefficient that is raised to the power. So is it clear? Shall we move on to biomolecules? Tell me. 1 घंटा 50 minute and we have completed the basic chemistry. I think in whole of YouTube you will not find any other lecture which is having basic chemistry for physical science or for soil science, you know. Like basic chemistry देखना पड़ेगा तो NEET का, JEE advanced का, those videos are there, and also chemistry honors people's videos are there. But for soil science, basic chemistry, I think this is the first one. So if you have any doubt anywhere or you want to tell me anything else, you can tell me. Or you can put a thumbs up or write something so that we will move on. नहीं खत्म नहीं हुआ एक ही हुआ है. What is that board? Tell. Huh? Thank you. All right, is it fine? Shall we move on? Okay, I don't think anyone is there for response. So we will move on to biomolecules. At the end, we will see some few more things anyhow. So biomolecules, all of you know, इसमें we will only discuss the important questions because I know all of you have read already. We will only discuss the important questions. बाकी कुछ नहीं करेंगे इसमें. So biomolecules का सबसे first class of compound is carbohydrates. We all know it is carbohydrate. So carbohydrates are the most abundant biomolecule on earth. Now we will have a question for you. Which is the most abundant carbohydrate? Can anyone tell me? Which is the most abundant carbohydrate in the plant kingdom? And tell me the most abundant carbohydrate in the animal kingdom as well. Which are these two carbohydrates? ये भी, these are potential questions also, है ना? Most abundant carbohydrate in plant kingdom. Anyone would like to take a guess? Anything? Any guesses? Okay, no guesses. We have a lack of time now, so we cannot do anything. ठीक है, इसको याद रख लेना. Very important. Might come in the exam. ठीक है. The term saccharide comes from the Greek saccharon, which means sugar. All of you know. No, it's not chitin. Chitin carbohydrate नहीं है भाई. Carbohydrates are polyhydroxyaldehydes. Polyhydroxyaldehyde का मतलब है poly, many, hydroxy means OH groups. So there are many OH groups, and these are either aldehydes or ketones or substances that yield such compound on hydrolysis. That is called carbohydrate. Now classification of carbohydrate, we all know: monosaccharides, oligosaccharides, polysaccharides. Monosaccharides are low molecular weight carbohydrates. Low molecular weight, cannot be hydrolyzed further. Very important. Crystalline, soluble in nature, sweet in taste. All monosaccharides are reducing in nature. Very important. All monosaccharides are reducing in nature. ठीक है? Oligosaccharides contain 2 to 10 monosaccharide units joined by glycosidic bonds. Extremely important. The bond that is present in carbohydrates between each saccharide, that is glycosidic bond. ठीक है? Low molecular weight carbohydrates which can be hydrolyzed by enzymes or acids to yield monosaccharides. These are sweet in taste. Some of them are reducing, some of them are not. ठीक है? Monosaccharides, everyone is reducing. In case of oligosaccharides, some are reducing, some are not. In case of polysaccharide, everyone is non-reducing. These are non-reducing in nature. ठीक है? Contains many monosaccharides joined together by glycosidic bonds. These are also called glycans. Very important. They can be hydrolyzed by enzymes or by acids. जिसका example है cellulose, जिसको hydrolyze करने के लिए we need cellulase, है ना? These are non-reducing in nature and give deep blue or red color with iodine. These are the tests for the. So यहाँ पे these are not sweet. These are not sweet in taste. So यहाँ से याद आया, there was one PYQ in JRF where they asked for a diabetic patient what should we recommend. So the answer would be polysaccharide. We should recommend polysaccharide, है ना? Moving on, what is a monosaccharide? These are further classified based on the number of carbon atoms present in the monosaccharide into triose, 3 carbon, tetrose, pentose, hexose and heptose. Very easy. This is the example. Triose ka, aldose ka example है glyceraldehyde, because in the original example only we have seen okay, it can be both ketone and it can be both aldehyde. This is also very important. It can be both aldehyde and both ketone. So for you, I will draw the groups here. Aldehyde is CHO, that is COH. ठीक? And for ketose, it is. ठीक है ना? These are the groups. So these are the examples: glyceraldehyde, dihydroxyacetone. For tetrose, it is erythrose, erythrulose. You can see a pattern here. Whether you add this lose, it becomes a ketose of that same thing. Pentose and hexose are the predominant type of monosaccharide found in nature. This is also very, very important. ठीक है? The simplest monosaccharide that possesses a hydroxyl group and a carbonyl group with an asymmetric carbon atom is the aldose triose. इसका example है glyceraldehyde. This has been asked in the exam in the PYQ, इसीलिए इसको अलग से रखा गया है. Simplest monosaccharide that will be aldose triose and that will be glyceraldehyde, है ना? ठीक है? Very nice. Then if the hydroxyl group on the penultimate carbon is the second last, penultimate carbon is on the right hand side, then that is called the D family, and if it on the left side, it is called the L family. ठीक है? If the hydroxyl group on the penultimate carbon, ये क्या है वो we'll see on the next slide. D configuration is more common in nature. This is very important. And this is opposite to that of amino acid. In amino acid, L configuration is more common in nature. ठीक है? When an aldehyde or a ketone group is present in a molecule that also possesses hydroxyl group, an intramolecular arrangement may occur to form a hemiacetal or hemiketal. This also we will see what it is saying. And these are the two types of ring. Fine. Structure में आ जाओ. This is the D glucose. This is the L glucose. ठीक है? Can anyone tell what is this system called? जिस system में ये लिखा गया है. This is called a type of projection. What projection is this? I expect some answers because तुम सब लोग भाई बहुत सारे marks लेके आए हो 11th 12th में, पढ़ के तो आए हो भाई. And also you have done your biomolecules class, biochemicals class in the biochemistry course, जो BSc में पढ़ना होता है. So this is which projection? This type of writing is called Fischer projection. So here the compounds you are seeing, it is written in Fischer projection. In this, you can see the functional group is here. So यहाँ से लेके we have read the penultimate carbon. ठीक है ना? Very nice, Shreyoshi. This is the last carbon. This is the penultimate carbon. That is the carbon before the last carbon. In this, if the OH group is present on the right side, it is called D glucose. If it is present on the left side, it is called L glucose. And याद रखना capital L and capital D. Small d, small l अलग हो जाता है. That is completely different. This is capital D and capital L. ठीक है? ये समझ में आ गया? In Fischer projection, when we'll write like this, in the penultimate carbon, if the OH is on the right hand side, it is D glucose. If it is on the left hand, it is the L glucose. ठीक है? तो ये statement हमें समझ में आ गया. Now it is telling in a molecule that also possesses a hydroxyl group, and intramolecular arrangement might take place. ठीक है? Intramolecular arrangement might take place का मतलब क्या है? This functional group का कार्बन जो है, this will react with this carbon. Sorry, not this. This will react with this carbon. ठीक है? Since it is nature, in nature you will not find it like this, definitely. This carbon will react with this carbon and it will form a 6-membered ring. देखा ना, यहाँ पे यही लिखा है. Intramolecular arrangement may occur to form a hemiacetal or hemiketal respectively. Since this is a aldehyde group, after the formation of this ring, it is called a hemiacetal. And see, यहाँ पे लिखा है 2 types of ring structures are possible. 5-membered ring अगर form हुआ, that is called furanose. It is easy to remember, F and F. And it is a 6-membered ring, then it is called a pyranose, if the carbonyl group interact with hydroxyl group. So ये याद रखना. In this case, this carbon will react with this. तो carbon कितना हुआ? 1, 2, 3, 4, 5. ठीक है? So 5-membered, it will form a furanose. If it forms 6-membered, if this reacts with this, the 6-membered ring will be called pyranose. ठीक है? Anomers. We are coming into isomerism now. So isomeric form of monosaccharide that differ only in their configuration about the hemiacetal or hemiketal carbon atom. इसका मतलब क्या है? In this ring formation, when this will form a ring, it will somewhat look like this, right? 1, 2, 3, 4, 5 carbon है. So 1, 2, 3, 4, sorry. What I was telling, this when this aldehyde is present, like for glucose, it will form a pyranose, that is a 6-membered ring. In case of ketone, it will form a furanose. अगर ketone होता तो it would have reacted with the 4th carbon, that is a 5-membered ring. अब इसको ड्रॉ करना मुश्किल हो रहा है यार. All right. This is the 6-membered ring we are talking about, because this has come here and see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 carbon hai. Now this carbon, in this carbon with which this is there, so it will be CH2OH, and in the other side it will be H. ठीक है? This is called a anomeric carbon. Here we are seeing that only. In case of anomers, differ only in their configuration about the hemiacetal or hemiketal carbon atom. This carbon is the hemiacetal or hemiketal carbon atom. It is also called the anomeric carbon. ठीक है? इस anomeric carbon में, if this CH2OH is below, ये अगर नीचे है, so it is called alpha. So it will be alpha D glucose. ये अगर ऊपर है, so that will be beta. That is called a beta D glucose. So in the compounds you will see alpha 1 के साथ beta 2 का bonding हो रहा है. What are those? These are this. And this projection is called Fischer projection, and this ring type of projection, that is called Haworth projection. ठीक है? ये जरूरत नहीं है, सिर्फ जान लो. ठीक है? So what is anomer? So only this. In this, if this CH2OH is नीचे and if this CH2OH is ऊपर, those two are called anomers. So it only differs in this carbon. ठीक है? Then those are called anomers, and that carbon is referred to as anomeric carbon. The cyclic forms of carbohydrates can exist in 2 forms, alpha and beta, based on the position of the substituent at the anomeric center. When the newly formed OH group at C1 lies below, it is called alpha anomer. When it lies above, it is called a beta anomer. Alpha D glucose and beta D glucose are called anomers of each other. Is that clear? Can anyone tell me? Please put a thumbs up because please, if it is clear, please write yes or anything, or if there is any doubt, you can ask. ठीक है, so we have understood what is anomer. Then coming to mutarotation. What is mutarotation? Conversion of alpha D glucose to beta D glucose and vice versa in aqueous solution is called mutarotation. In solution, specific rotation of alpha D glucose changes from this to this. This change in optical rotation is called mutarotation. This is very easy. इसमें समझने का कुछ नहीं है. Then stereoisomerism. It is a form of isomerism in which molecules have the same molecular formula and sequence of atoms, but they differ in three-dimensional orientation of atoms. Three-dimensional orientation of atoms in space. Stereoisomers have same formula. Glucose has 16 stereoisomers. If number of asymmetric carbon is n, then the number of stereoisomer is 2 to the power n. ठीक है? It will depend on the number of asymmetric carbon in the compound. Asymmetric का मतलब क्या है? In the four sides there are four different constituents are present. That is called the asymmetric carbon, which is also called chiral carbon, है ना? It is also called a chiral center or a chiral carbon. ठीक है? Knowing this is tough, I can understand, but you have to remember this because यहाँ से question आता है. इसका जो examples है, the best way I will tell you, सबके पास अभी ChatGPT है, Google Gemini है. In that you just write the name of this and you just write the examples. They will give you the best example possible. And ये भी possible है कि exam में वो लोग ChatGPT से ही question बना के देगा. So there is a chance you might get that. ठीक है? Then what is enantiomer? These are stereoisomers which are mirror images of each other but are not superimposable. So these are called non-superimposable mirror image. Mirror image एक के साथ एक superimpose हो जाता है, but in this case these are non-superimposable mirror image of each other. It has the same physical property. Example, D and L configuration. See, these are the two mirror images of each other. लेकिन इसको उठा के लाके अगर ऐसे बिठाओगे, so it will be non-superimposable image because of this carbon, है ना? So these are called enantiomers. So enantiomers, anomers, I think पता चल गया. Now what is diastereoisomer? Diastereomer are stereoisomer that are not mirror images. Mirror image अगर हुआ तो enantiomer, mirror image अगर नहीं हुआ तो it is diastereomer. D-glucose, D-mannose, D-galactose and other members of aldohexose are example of diastereomer. Glucose has 14 diastereomer. ये तो याद रखना पड़ेगा. I cannot help you here. Now what is epimer? Epimers are monosaccharides differing in configuration at a single carbon atom other than the carbonyl carbon. ठीक है? Galactose and glucose are epimers with respect to carbon 4. Mannose and glucose are epimers with respect to carbon 2. This has been mentioned because this is a previous year question of 2022 JRF. ठीक है? So epimers also will differ in configuration only in a single chiral carbon. Only in a single chiral carbon other than the carbonyl atom. Like this cannot be hold. जो functional group है हम उसको नहीं ले सकते, उसको छोड़ के in any one single carbon atom it will differ in configuration. ठीक है? This is very important. This line is very important. This second line इसको याद रखना because this is a previous year question. ठीक है ना? Previous year question. All epimers are diastereomer, but all diastereomers are not epimers. ठीक है? Because all epimers are diastereomers because diastereomers are isomers that are not mirror images. लेकिन all diastereoisomer are not epimer because epimer का condition है only one carbon, only one single carbon में there will be change. ठीक है? Now जो मैं वहां पे बोल रहा था D and L उसको हमेशा कैपिटल में वहां पे लिखना है because it indicates something. Small d and small l it indicates some other thing. वो क्या indicate करता है? This optical isomer. When the plane polarized light is rotated to the right, the compound is dextrorotatory, which is denoted as plus. And the plane polarized light when rotated to left, it is called levorotatory and written as minus. These are called optical isomer. इसका मतलब क्या है? इसका मतलब है say there is a mixture जिसमें सिर्फ D glucose है and you are sending a plane polarized light through this solution, then this light will be rotated in the right direction. If it is rotated in the right direction, it is called D glucose. if it is in the left it is called L glucose. ठीक है, this D का मतलब है डेक्स्ट्रोरोटेटरी, दिस इज लिवोरोटेटरी, एंड यहाँ पे जो हमने D और L का बात किया these are completely different. ठीक है, सो दोनों में कभी भी कंफ्यूज मत होना. This small d and small l, this is also written as plus and minus. ठीक है, ठीक है, फाइन. These are called optical isomers. Then जो D और L था वो क्या था? Small d and small l are optical isomer, but capital D and capital L, these are enantiomer, है ना? I understand it can be a bit problematic, लेकिन बाद में एक बार देख लेना अच्छे से ठंडे दिमाग से. It is very easy. You don't have to worry about it. Mirror images of each other, but not superimposable. Those are capital D's, capital L. In case of optical isomer, small d, small l. Here you can see what I was telling. This is alpha glucose because this OH is located in the below, है ना? नीचे है. I think here I drew it a bit wrong. It will not be CH2OH, na? Sorry. It will be only OH. Yes. So here you can see in this image, this is a alpha glucose, this is a beta glucose, because the OH is on the upper side in this Haworth projection. Since this is a 6-membered ring, it is called a pyranose. याद रखना easy है. If it was a 5-membered ring like this, then it is called a furanose. 5 or furanose, FF, याद रखना easy है ना. When both dextrorotatory and levorotatory isomers are present in equal amount, it is known as a racemic mixture. This is also very important. Racemic mixture is when both small d and small l plus and minus are present in equal amount in a mixture, that is called a racemic mixture. So now we are coming to D-glucose and D-fructose. It differs in the position of carbonyl group. That is, aldehyde group is present, I told you already. Aldehyde is group is present at the end of the chain, whereas ketone cannot be present at the end of the chain because it has 2 bonds, so it can be in the second position. So aldehyde and ketone group, D-glucose and D-fructose, differ in the position of carbonyl group. These 2 compounds are called functional isomer because इसका functional group अलग-अलग है. Glucose and fructose are functional isomer because this carbonyl group, functional group is different. Glucose का है aldehyde, fructose का है ketone. ठीक है? Conversion of D-glucose to D-fructose is called tautomerism. Very important. Now, glucose can be reduced to sorbitol. This is fine. This I don't think is important. All monosaccharides are reducing. Very important. The reducing property is due to the ability of these sugars to reduce metal ions. इसको reducing क्यों बोलता है? To reduce metal ions. And as copper, silver to form insoluble cuprous oxide under alkaline condition. The alkaline, fine. This depends on the presence of potentially free aldehyde or keto groups. ठीक है? This is very important from the exam point of view. This whole slide is only containing questions. इसमें समझाने का कुछ नहीं है because एक टेस्ट को अगर समझाने जाएंगे तो बायोमोलिक्यूल्स का ही 4 hours का क्लास लेना पड़ेगा. That is not possible now. So you have to remember the name of the test. Monosaccharide give positive result to Fehling, Benedict and Barford's and Nylander's test. Barford's test is for monosaccharide. Fehling, Benedict, Tollens test are for reducing sugars. Reducing sugars, all monosaccharides are reducing sugars. है ना? Alpha naphthol and Molish test are for general carbohydrates. Seliwanoff's test differentiates between aldose and ketose. Example, glucose and fructose. This is very important. I think you have read this all in 11th and 12th. I remember I have read them. Bayer's test is to differentiate between hexose and pentose. This whole slide is extremely important. If you want, you can take a screenshot of this and read it in your time. ठीक है? इसको याद रखना ही है. All this, everything that is written here, you have to remember. ठीक है? Now coming to oligosaccharide. Oligosaccharides are commonly encountered in nature. They belong to disaccharide. Disaccharide consists of 2 monosaccharide. This is very easy. By glycosidic bond, reducing end of the other, fine. If both anomeric carbon atoms of monosaccharides are involved in glycosidic bond formation, that results in the formation of a non-reducing disaccharide. इसमें deep से तो question नहीं आएगा, लेकिन non-reducing disaccharide का example आएगा, and non-reducing disaccharide का best example है sucrose. This I have seen in many PYQs, है ना? So please be very aware. Sucrose is the best example of non-reducing sugar. It is the non-reducing disaccharide. ठीक है? And it forms of alpha D glucose and beta D fructose. अल्फा बीटा सब हमें अभी पता है, डी पता है, डी पता है, अल्फा बीटा पता है, फ्रुक्टोज ग्लूकोज सब पता है. So I think you are having some understanding now. It is nice. And this linkage is nothing but the carbon number. पहला compound का carbon number 1, दूसरा compound का carbon number 4. Similarly 1 4, similarly 1 2. ठीक है? Then trisaccharide हमें अलग से पढ़ने का जरूरत नहीं था because it comes under oligosaccharide only, but we have given this only for this example because this is very important and it might come in exam. Raffinose is made up of glucose plus galactose plus fructose. Just for this line we have given this. It is present in high amount in seeds of leguminous plant. It serves as a reserve material. This is also very important. ठीक है? After sucrose, raffinose is the most widely occurring oligosaccharide in plant kingdom. This is also very important. Bengal gram has high amount of raffinose. So whatever is written here about raffinose, very important. Please remember. Okay? Now what is inversion of sugar? The hydrolysis of sucrose when followed polarimetrically, the optical rotation changes from dextro to levo. We all already know what is dextrorotatory, what is levorotatory. So उसमें जो change होता है, the dextrorotatory sucrose on hydrolysis yield levorotatory mixture of glucose and fructose. This reaction is enhanced in acid medium and high temperature. This phenomenon is called inversion and the mixture of glucose and fructose is called invert sugar. If you are a fan of packaged foods and all, in that you will find the mention of this invert sugar. Invert sugar का मतलब क्या है? Invert sugar is nothing but this. In honey also you can find invert sugar. जो original honey नहीं होता है, उसमें invert sugar रहता है. What is invert sugar? Hydrolysis of sugar followed polarimetrically, where dextrorotatory sucrose on hydrolysis yield levorotatory mixture of glucose and fructose. This reaction is enhanced in acid medium and high temperature. Acid medium और high temperature में जब fructose का hydrolysis किया जाता है, it gives levorotatory glucose and fructose. Inversion हुआ, पहले D था, D sucrose था, then it became L fructose and L glucose. That is inversion हुआ. That is why it is called inversion and it is called invert sugar. This reaction is catalyzed by the enzyme invertase. Invert sugar is sweeter than sucrose. That is why it is used in various packaged foods. If you clearly read the label, in that you can see. है ना? Invert sugar. Now coming to polysaccharide. They are classified depending on functional classification is structural polysaccharide, storage polysaccharide. इसका सिर्फ example देखना है. Structural is cellulose, hemicellulose. Sorry Shreyoshi, chitin is also polysaccharide, but it is not the most abundant. Most abundant is glycogen, है ना? Storage. See this one. This glycogen is the most abundant. Okay. I apologize for that time. Chitin is also a structural polysaccharide, but it is not the most abundant. Most abundant in plant kingdom is cellulose. In animal kingdom, it is glycogen. Chitin का animal kingdom में नहीं आता है because mostly it is present in fungus, no? Fungi में भी रहता है. That is why. Now in this, here you can see inulin. This is different. This is inulin. And this is not insulin. ठीक है, इसमें confuse मत होना और जाके लिख के मत आना कि insulin is also a polysaccharide. हमें तो बोला गया था, रौनक ने तो बोला था, भाई इंसुलिन एक प्रोटीन है, वो एंजाइम है, ठीक है ना? इंसुलिन comes under protein. Sorry, एंजाइम नहीं है. इंसुलिन is what? इंसुलिन is hormone. Please do not get confused between insulin and inulin. ठीक है ना? Insulin and inulin are two completely different things. Insulin is a peptide hormone. It is a hormone. ये polysaccharide नहीं है and we know hormones are proteins. It is a peptide hormone. ठीक है? Nature of branching के हिसाब से linear and branched. In linear, example is again cellulose chitin. In branched, it is starch and amylopectin. ठीक है? Then repeating unit, homopolysaccharide, heteropolysaccharide, all of you know if the repeating unit is same, it is homopolysaccharide. If the repeating unit is different, it is heteropolysaccharide. Heteropolysaccharide में hemicellulose pectin, homo में आता है starch, glycogen, chitin, inulin. Polysaccharide intake can effectively ameliorate and is safe for diabetes. I have already told this, ये PYQ में आ चुका है, that is why we have put it here, right? Now moving on to starch. It is the principal food reserve in plant kingdom. Starch is an alpha glucan that has structurally distinct components called amylose and amylopectin, है ना? Amylose is unbranched polymer. Amylopectin is the branched polymer. ठीक है? Starch contains 25% amylose, 75% amylopectin. It has one reducing end and one non-reducing end. Amylose gives blue color with iodine. Amylopectin gives red color with iodine. The iodine test is used for distinguishing between starch, glycogen and carbohydrates. इसमें तो समझाने लायक कुछ नहीं है. It's sad. Then cellulose is the most abundant organic substance and polymer found in nature. It is the principal constituent of cell wall in higher plants. It occurs in almost pure form. Mammals, including humans, lack enzymes capable of digesting, and so we cannot digest the plant cell walls. Dietary fiber is cellulose. Dietary fiber is cellulose because we don't have the enzyme that is called cellobiase, which is present in cattle, that is not present in us. हमारे appendix में एक ज़माने में हुआ करता था, अभी नहीं हुआ करता है ना? Then glycogen is the glucose storage polysaccharide of animals. In this glucose are linked, it has many non-reducing ends but one reducing end only. ठीक है? Now here you can see use of saccharides. I don't think this is that important. You can take just a simple reading only. Biofuel ethanol, pharmaceuticals, orbital syrup, fructose. Rest I don't think is that important. You know it already. ठीक है? Now coming to protein. Is it clear? Is there any question? Then let me know. Is there any question from anyone? Please let me know. Someone has written, Niraj, is amylose water soluble? Yes, amylose is water soluble. Yes. So, moving on to protein, we will move on to protein. In protein also, can you tell me, protein का भी abundance का बात करते हैं, which is the most abundant protein in plants? In plant kingdom, which is the most abundant protein? And in animal kingdom, which is the most abundant protein? Anyone, please tell fast. हमें जल्दी जल्दी खत्म करना है भाई, बहुत टाइम हो गया. Anyone, which is the most abundant protein in plant kingdom? And that is overall also. Overall, which is the most important? Rubisco. Perfect. For animals, it is collagen. Exactly. Very nice. Very impressive. For animals, it is collagen. For plants, it is Rubisco, the enzyme, right? Ribulose bisphosphate carboxylase oxygenase. That is the full name, है ना? चलो. The word protein was coined by Berzelius. Very important. Berzelius ने नाम दिया था. Very important. Derived from the Greek word proteos, meaning first rank. All proteins are formed from 20 different amino acids. ठीक है? A total of 64 different codons, triplets of nucleotides. I think all of you know what is a codon. Synthesize 20 amino acid. Out of 64, 61 are sense codon and 3 are stop codon. That is the UAG, UGA and UA. Start codon is the AUG, which is for methionine. That is for methionine, not for methionine. It is ठीक है? For methionine. Then properties of amino acid. इसको पढ़ लेना. I don't think there is anything explainable here. They can react with both alkalis and acids to form salts. That is why they are also called amphoteric. है ना? They are also called amphoteric. Here you can see amino acids are amphoteric compounds. They contain both acidic group and basic group. Amino acid, amine group है, which is basic. Acid group है, which is acidic. Since it is both acidic and basic, it can react with both acid and alkali. That is why they are called amphoteric. यहाँ पे लिखा है they can react with both alkali and acid to form salts. ठीक है? बाकी यहाँ पे देख सकते हो high melting boiling point, white crystalline substance, sweet, tasteless, bitter, anything can be the taste. Most of the amino acids are soluble in water and insoluble in organic solvents. Fine. In acid solution, amino acid carry positive charges. Again, this is the simple concept of origin of charge that we have read. If there is acid solution, बहुत सारा H plus का vicinity है, so it will carry a positive charge and hence they move towards cathode in electric field. In alkaline solution, the amino acid carry negative charge because when there is many OH minus, it will take the COH का जो H plus है इसको लेके भाग जाएगा. Simple बात है. So it will have COO minus charge. It will have a minus charge. It will carry negative charge. In case of acidic medium, NH2 में जाके it will form NH3 plus. ठीक है ना? It will. This is simple origin of charge जो हम पढ़ के आए हैं in clay colloids. Same concept. In alkaline solution, it will carry negative charge and therefore move towards anode. Then what is a Zwitter ion? Zwitter ion is nothing but again that ZPC concept of soil colloid. Zwitter ion, there is an internal transfer of hydrogen ion from the COH group to NH2 group to leave an ion with both a negative charge and a positive charge. It exists an inner salt carrying both positive and negative charge. Amino acid possessing both positive and negative charge are called Zwitter ions. It is a form which possesses both positive and negative charge. यानी कि जो COH है उसके साथ OH minus react करके negative charge बना दिया, जो NH2 है उसके साथ H plus protonate होके NH3 plus बना दिया. So both positive and negative charge, it will be Zwitter ion. Then isoelectric point, again exact same concept of that of soil colloid, origin of charge. It is the pH at which the amino acid has no tendency to move either towards positive or negative is called isoelectric pH or isoelectric point. At isoelectric point, the amino acid molecule bears a net charge of 0. So जितना भी negative charge है, CO minus जितना भी है, that is all balanced by NH3 plus and that results in a isoelectric point. Fine. Then again isomerism. Except glycine, all other amino acids possess asymmetric chiral carbon which is next to the COH group. Because of the presence of asymmetric carbon atom, it can have optically active form. So it is called D amino acid and L amino acid, same that we have read before. Here I have again mentioned it. It do not refer to the optical rotation. Optical rotation अगर refer करेगा तो it will always be small d and small l. ठीक है? Direction of optical rotation is indicated by the symbol plus minus which follows the designation small d and small l. ठीक है? Naturally occurring amino acids are L amino acids, whereas naturally occurring saccharides, monosaccharides are the D monosaccharides. Okay? We have already read that. So this is the amino acid. You can see this is the alpha carbon, which is the anomeric carbon, because in 4 sides there are 4 different groups. That is why it is a chiral carbon. It is called a chiral carbon. It is having 4 different constituents on 4 different sides. Hai na? So here you can see this is our batches. The mock test series you can get for 399 and this is the Shrestha batch for 2027. I will not tell about 26 anymore, lekin kyunki abhi exam hai, I know. So 2027 batch is starting. I am also there and you can consider joining it. We will be starting it very soon and we will just read. So whoever at the junior batches watching this video, you can consider joining. Essential amino acids, the amino acids. Essential का मतलब क्या है? This is very interesting. Amino acids which are needed for normal functioning of the body but cannot be synthesized in our body. जो हमें चाहिए लेकिन हम बना नहीं सकते, हमें बाहर से लेना पड़ेगा. That is called essential. जो हमें चाहिए और हम खुद बना सकते, that is not essential. वो तो हमें मिल ही रहा है. लेकिन जो मिल नहीं रहा है, बाहर से लेना पड़ रहा है, that is called essential. These are essential amino acid. इसका examples methionine, arginine, threonine. Please be very, very thorough with this. चाहो तो screenshot ले लो and read this. You have to remember this. There is no other way. ठीक है? Then chemical reaction. This is not that important. This is very important. Ninhydrin test. Ninhydrin test is the surety test of alpha amino acid. ठीक है? याद रखना. Amino acids having NH2 group will give positive result. These are also again the same. These are the tests for the determination of amino acid. It works as quantitative estimation of only alpha amino acids. ठीक है? Only alpha amino acids. इसको याद रखना है. Alpha amino acids को ही ये determine कर सकता है. Then Hopkins Cole test and xanthoprotic test is for the specific. इसको देख लेना. Then important facts. Important facts इसीलिए दिया गया है क्योंकि यहाँ से question आता है. Proline is synthesized in plants during water stress. All of you know this. Very important. sulfur containing amino acids cysteine and methionine, and also cysteine, cysteine and methionine. These three cereals are deficient of lysine and tryptophan but deficient in sorry for the typing mistake. This PPT was not made by me actually. I should have checked it. Anyhow, cereals are deficient of lysine and tryptophan, but it has abundant quantities of, it is not deficient, abundant quantities of cysteine and methionine. Pulses are deficient in cysteine and methionine, but rich in lysine and tryptophan. Okay? That is why there should be a combination of pulses and cereals for a balanced diet. ठीक? Because pulses are deficient in cysteine methionine, cereals में cysteine and methionine है, whereas cereals are deficient of lysine tryptophan जो कि pulses में है. ठीक है? इसको याद रखना. This is abundant. This is a printing mistake. Apologies for that. Peptide bond. जैसे हम पढ़ के आए हैं, in carbohydrates it is the glycosidic linkage. In case of proteins it is the peptide bond. Amino acids are linked together by formation of covalent bonds. These bonds between alpha carboxyl group of one amino acid and the alpha amino group of the next amino acid and the elimination of water molecule, this is called a peptide bond. This is nothing, you can easily understand here. यहाँ से COOH है, यहाँ से NH2 है, यहाँ से एक H2O molecule को निकाल दो, then it will form, that is a peptide bond. ठीक है ना? Now these are the classification of proteins. Simple proteins yield only amino acid on hydrolysis. इसका classification is very important. Please read this: albumin, globulin, prolamine, gluteins, histones, proteins and albuminoids. इसका examples भी दिया हुआ है. You can take a screenshot and you can read. इसमें समझाने का कुछ नहीं है. Then similarly for compound proteins are differing from simple protein in the fact that they are combined with non-protein substances known as prosthetic groups. This is a very potential question of examination. Non-protein substance in proteins are called prosthetic group. That is found in compound proteins, where the simple proteins combined with non-protein substances known as prosthetic group. So compound protein is simple protein plus prosthetic group. उसका भी example है nucleoprotein. Here you can see nucleic acid के साथ combination है. Mucoproteins is formation with mucopolysaccharides. Chromoproteins with colored prosthetic groups. Lipoproteins with lipids. Metalloproteins with metals. Phosphoproteins with phosphoric acid. ठीक है? I think that is clear. You can read these examples also. Very easy. Then derived proteins are proteins derived by partial to complete hydrolysis from the simple or conjugated proteins by the action of acid, alkali or enzyme. Derived का मतलब देख के पता चल रहा है that has been derived, that does not occur naturally. ठीक है? Primary derived protein, that is the coagulated protein, metaprotein, proteins, and secondary derived protein are this one. Here you can see this combination, sorry, this sequence: proteose, peptone, peptide and amino acid. ठीक है? So conformation of protein is very important. I think all of you have read this already in your 11th and 12th. The protein structure has been classified into 4 different levels based on their folding pattern and folding conformation. That is primary structure, secondary structure, tertiary structure and quaternary structure. So in the primary structure, that is a simplest level of structural organization. It refers to number of amino acids in the order linked together. Determination of C terminal, N terminal is done. Fluoro, fine. ये और जरूरी नहीं है. Secondary structure, this is very important. हाँ, this is very very important. Secondary structure में दो होता है. One is alpha helix and another is beta sheet. Alpha helix and beta pleated sheet. There are two types of secondary structure. So primary structure, imagine it as a long chain of amino acid. That chain is folding and conforming in different types to form a alpha helix and a beta sheet. Helix का मतलब आपको पता है, helix is nothing but like this, it is a helix. Whereas beta sheet it forms like a asbestos का जो sheet होता है उस हिसाब से it forms a sheet like structure. ठीक है? Alpha helix is the most stable arrangement of polypeptides. The helix structure of protein is stabilized by intramolecular hydrogen bonding. जब helix form हो रहा है तो different hydrogen bonding comes into play. ठीक है? hydrogen bond is formed between every first and the fourth amino acid of the helix. Very, very, very important. This slide is very important. Please read it very thoroughly. है ना? Beta sheet are composed of two or more different polypeptide chains. This structure is a result of intermolecular hydrogen bonding. ठीक है? This is intramolecular hydrogen bonding. This is intermolecular hydrogen bonding because there are more than one peptide chain is involved. In this, only single peptide chain, it will form a helix. So every first amino acid and every fourth amino acid will have a bonding, hydrogen bonding. Okay? Then in beta sheet, the chains running in the same direction, parallel pleated sheet structure, and when opposite, it is called anti-parallel sheet structure. Okay? We have photos of this also, don't worry. Tertiary structure is, it is very common sense only. It refers to the complete three-dimensional structure of the polypeptide units of a given protein. Tertiary structure is maintained by hydrogen bonding, hydrophobic interactions, disulfide bonds, interaction, salt linkage, and van der Waals forces. Hydrophobic forces is the most important determinant of the tertiary structure. Then finally, quaternary structure, it contains two or more different polypeptide chains that are held in association. Proteins with multiple polypeptide chains are oligomeric proteins. Proteins with identical substitute are termed homo-oligomers. Example, you can see. Here you can see this is a primary polypeptide chain. This forms alpha helix, then it forms a beta pleated sheet. This is the tertiary structure, and finally the quaternary structure is the final part. Okay? Now denaturation, all of you know, it is the physical change in which there is a collapse of the protein structure. There is a decrease in solubility and loss of biological activity of proteins. Denaturation occurs at extreme temperature and pH. Renaturation refers to attainment of original regular three-dimensional functional protein. Denaturation का best example है if you boil an egg. So जो protein है उसका denaturation, it is a physical change in which there is a collapse of the protein structure, whereas renaturation is somehow you are attaining the original dimensional function protein after its denaturation. So D and re. Okay? Then biurate test, very important. I think all of you know what is biurate. It is present in urea also. It is extensively used as a test to detect proteins in biological materials. A compound which is having more than one peptide bond when treated with biurate reagent produces a violet color. Bigger molecules are retained. Then gel filtration and chromatography is used to separate protein based on their sizes. This is also very important. Then mass spectrometry is an important method for accurate mass determination and characterization of protein. This is also very important. Okay? Now, finally, we have come to lipids. This is the ending part. The word lipid is derived from lipos, meaning fat. All of you know, lipid is fat. Lipids are chemically heterogeneous group of compounds that are insoluble in water but soluble in non-polar solvents such as chloroform. Lipids are storage and structural components both. Lipids are essential for fat-soluble vitamins, that is A, D, E, and K. Adrenal corticosteroids and all these are synthesized from lipid derivative, that is the cholesterol. Then classification, lipids are classified into two major groups. One is non-saponifiable and another is saponifiable. Saponifiable is, it cannot be disintegrated into smaller molecules, that is non-saponifiable. Saponifiable is, it comprises one or more ester groups enabling it to undergo hydrolysis. Hydrolysis अगर है तो saponifiable, अगर नहीं है तो non-saponifiable. ठीक? Lipids can also be simple and compound. Simple lipids contain only alcohol and fatty acids, whereas compound lipids, it can contain other things as well. Okay? So here you can see alcohols and fatty acids. So iska formation hua. So this is a simple lipid. Okay? Now we have come to enzyme. In enzyme, everything is important, so you have to read everything. Enzyme term was given by Kuhn. Very, very, very important. Enzymes are biocatalyst, again very important. They speed up the reaction. Enzymes are proteins, again very important. Enzymes are proteins. They are extremely specific to their substrates, very important. They remain intact after reaction. Enzyme reduces the activation energy without affecting the free energy. It is just like a catalyst. Catalyst का काम होता है reaction में participate नहीं करना, reaction का speed को बढ़ाना, and how they increase that speed? By lowering down the activation energy. Enzyme exactly does that. It does not take part in the reaction. They only speed up the reaction. ठीक है? They remain intact after reaction. Fine. Then holoenzyme is hollow enzyme. कैसे याद रखना है? Hollow. Hollow means whole. Remember it as whole. hollow enzyme, the whole enzyme. It is composed of apoenzyme, protein portion plus cofactor. ठीक है? An enzyme and its cofactor together constitute the hollow enzyme. The protein part of enzyme is called apoenzyme or apoprotein. ठीक है? Cofactors are non-protein substances that associate with enzymes. There are three types of cofactors: coenzyme, prosthetic group, and metal ion. Prosthetic group हम already पढ़ के आए हैं. Coenzyme are defined as organic molecules loosely bounded non-protein which are also termed as co-substrate. Example: vitamin A, vitamin B. Prosthetic groups are organic compound and tightly bound to the apoenzyme in covalent bonds. Example: heme in hemoglobin, biotin FAD. Metal ions in certain enzymes, a metal ion is required at the active site to form coordinate bonds. That is why metals are also required. Why is metal required in human body and in plant body? Because in certain enzymes, a metal ion is required at the active site to form coordinate bonds. Enzymes containing metal ions as cofactor are called metalloenzyme. इसका सबसे best example है cyanocobalamin, vitamin B12 that contains cobalt. And also अगर plant में देखोगे तो बहुत सारा है. Nitrogenous में we need molybdenum, urease में we need nickel, है ना? So many are there. So जो metal रहता है, that metal अगर रहा, it is called metalloenzyme. That metal ion comes under the cofactor section. This cofactor section along with the protein portion forms the hollow enzyme. This is extremely important. I cannot emphasize how important is this. यहाँ से बहुत सारे question आ सकता है. What is apoenzyme? What is cofactor? What is hollow enzyme? Cofactor का क्या क्या type है? Coenzyme क्या है? Prosthetic group क्या है? Metal ions क्या है? उसका different types. ठीक है? This whole slide is extremely important. Fine. Then vitamins, enzyme हो गया, vitamin. The term vitamin was coined by Funk. This is also very important. Question आ सकता है. Vitamins are organic compounds which are not synthesized within the body except vitamin D. Very important statement. Not synthesized within the body except vitamin D. They are found in minute amount in natural food or sometimes they are produced synthetically. Helps maintaining the metabolic functions. Provitamins are biologically inactive compounds which are quite similar to the vitamin, but they transform into active vitamin in vivo. This we have also read in the chemicals class also. Pro-pesticide, which is not a pesticide, but inside the living system, it becomes one active. Similarly, provitamin is not a vitamin, but when it enters the living system, it becomes an active vitamin. ठीक है? Biologically inactive है बाहर. When it enters the system, it becomes a active vitamin. Then antivitamin are chemical compounds that inhibit the absorption or action of vitamin. For example, avidin is protein in raw egg whites that inhibits the absorption of biotin, fat soluble vitamin and water soluble vitamin. तो ठीक है. Now this is the most important table of whole biomolecule class. From this table at least 2 question तो मान लो आएगा ही आएगा. It is very 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 important. Minimum 2 question is coming from this table. You can मान के चलो और उससे ज्यादा भी हो सकता है. ठीक है? This is very important. इसमें समझाने का कुछ नहीं है. You can take a screenshot and read as it is, or you can read. You have to remember all the chemical names because in PYQs they have asked which chemical name is for which vitamin. Vitamin B5 is also called. Then they have given the options. So B5 अगर pantothenic acid याद नहीं है तो you cannot do that question. B3 niacin अगर याद नहीं है तो you cannot do the question. This table is extremely important. Please take a screenshot. जो करना है करो, but please remember this. And these are the, whatever is written in bold, these are the characteristic typical diseases that happen due to that vitamin deficiency. These are also very important. That's why whenever there is a talk of vitamin C, तुम्हारे mind में तभी आ जाना चाहिए कि अरे scurvy. Vitamin C, scurvy. Vitamin D, rickets. It should be that, you should be that thorough. ठीक है? Then niacin, niacin में pellagra. Instantly you should be able to remember and you should do. All right, that ends our today's class. We will do some questions now. If anyone is there, anyone is interested, you can tell me. First you tell me what is the answer of this question. Anyone? Anyone? We have already read this in the start section, huh? Which of the following statement is incorrect? Please read the question अच्छे से. उसके बाद आंसर दो भाई, बहुत टाइम है हमारे पास. Don't worry, इसके लिए तो बहुत टाइम है. Option 4. All right, we will go on to the start slide and we will see, है ना? Blue color. Achha, it was not written here. We have not read that today. I think we have missed that, no? Very sad. What is the answer you are telling? Option 4. Definitely. अगर पता नहीं भी है तो पता चल रहा है they have asked the same question, same statement twice. तो इन दोनों में से एक तो आंसर होगा ही. These two are not the answer. So I have already told while studying that amylose is the water soluble fraction. So the correct answer will be option 4. Amylose is water insoluble fraction. Now tell me, this is a very brilliant question of my JRF time, you know. This is the best question of NTA. They have asked this question in JRF 2023. So can anyone tell me what is the answer? Which of the following is an amino acid? Cysteine, histidine, proline, glycine. इसमें से कौन सा amino acid है? Can anyone write that? All right, we have a thoda sa lack of time hai. Another mentor is going to take another class. So all are amino acids. Exactly. This was asked in 2023 and iska correct answer hai all are amino acids. This is a very brilliant question from NTA to give you some marks, you know. What type of covalent bond link the amino acid in a protein? I think all of you know that. इसमें हम time बर्बाद नहीं करेंगे. Peptide bond. Equivalent weight of a salt depends on. Today only we have read. In case of salt, in case of acid, it is basicity. In case of base, it is acidity. In case of weight of oxygen, so it is applicable for all. So equivalent weight of a salt depends on number of equivalent weight of an acid that combine into a salt. Right? ठीक है. Then quantity of Na2CO3 required to prepare 500 ml of 0.1 normal Na2CO3. इसको भी you calculate it and do. I remember the answer already, but I would say you calculate it and you put the answer in the comment section. 500 ml 0.1 normal. पहले इसका molar weight निकालो, molecular weight निकालो, then इसका equivalent weight निकालो, ठीक है ना? Then equivalent weight in one, that is normality. If you want, I can tell you normality, molarity and molality. If you want, only then I can tell those three in very short. If you want that, you can write in the live chat. Otherwise, we'll move on. Okay? Then this is also another brilliant question from NTA in our time only. It was given in yes sir, we need. ठीक है, हम बोल देंगे after the question ends. We will tell. So this was also asked in 2023 JRF. This is also a very brilliant question from NTA where no answer is correct actually. This question was dropped because here you can see they have asked to following carbohydrate molecule in increasing molecular weight. Increasing तो सबसे छोटा definitely is monosaccharide, but here you can see no option is having C as the least. So no answer is correct. इसका correct answer होगा सबसे पहले होगा C, then B, then D, then A. ठीक है ना? Then moving on. This question, do this question. This question is very important. Enzymes enhance reaction rate by a factor of 2 to 10. Activation energy of reaction is lowered by enzyme. This is a correct statement. Interaction between enzyme and substrate are hydrogen ionic hydrophobic bond. This is also correct statement. Substrate concentration does not affect. This is a wrong statement. This statement is also wrong because factor of 2 to 10 is very less. Enzymes can enhance the reaction by a factor of 10 to the power 5, 10 to the power 7 like that. So B and C is the correct answer. Here this I have already told. Please tell me the answer of this. जिन्होंने class किया है पूरा उनको तो पता होना ही चाहिए. I have told this full. When the benzene ring is a substitution in a molecule, it is known as. I have told this. See, they have told here. They have given here phenol. Yes, the correct answer is phenyl. Phenol has been given only to confuse you. So the correct answer is phenyl. है ना? Now this question comes under radioactivity. I thought of doing this question, but we are very short of time. So still we will try to do that. रेडियो एक्टिविटी का क्वेश्चन ये हमने कराया नहीं था, बट दिस केम इन माई JRF ऑल्सो, सो इन माई JRF ओनली, सो आई थॉट वी विल डू दैट. सी, व्हाट इज द एवरेज लाइफ ऑफ ए रेडियोएक्टिव एलिमेंट हुज हाफ लाइफ इज 30 डेज. ठीक है, अगर कोई फॉर्मूला याद नहीं है तो just go to the initial reaction of radioactivity, that is n equal to n0 lambda minus e to the power t. ठीक है, दिस इज द ओरिजिनल रिएक्शन ऑफ रेडियोएक्टिविटी. अब यहाँ पे t के जगह अगर हम t हाफ करेंगे, सो दिस n विल बी n0/2, n0/2 इक्वल टू n0 into lambda minus e to the power t half. So इसको अगर सॉल्व करोगे n0 n0 कट जाएगा, so it will come t half is equal to ln2 by lambda, that is t half equal to 0.693 by lambda. ठीक है, now this lambda is called the decay constant. sorry. ठीक है ना, ठीक है, बहुत बढ़िया. दिस इज द ओरिजिनल रिएक्शन ऑफ रेडियो एक्टिविटी, इसको हमेशा याद रखना. दिस इज ऑल्सो प्रेजेंट देयर इन बियर लैम्बर्ट लॉ एवरीवेयर, दिस ओनली. दिस इज द इनिशियल, दिस इज द फाइनल. सो व्हेन टी हाफ वी आर कैलकुलेटिंग, दिस विल बी n0/2, n0 कट जाएगा, एंड इसको टी हाफ को अगर सॉल्व करोगे, दिस टी हाफ विल कम ln2 डिवाइडेड बाई lambda. So T half will be 0.693 by lambda. Now this T half and this lambda is called the decay constant. लैम्बडा का वैल्यू जितना ज्यादा होगा उतना जल्दी जल्दी डीके होगा, लैम्बडा का वैल्यू जितना कम होगा उतना धीरे धीरे डीके होगा. बट नाउ व्हाट इज दिस एवरेज लाइफ? दे आर नॉट आस्किंग डीके कांस्टेंट, दे आर आस्किंग एवरेज लाइफ. याद रखना, एवरेज लाइफ इज 1 by डीके कांस्टेंट. एवरेज लाइफ इज 1 by डीके कांस्टेंट. सो यहां से फ्रॉम दिस फॉर्मूला यू कैन सी lambda is equal to 0.693 by t half. So average life मांगा है, तो 1 by lambda is equal to t half by 0.693, और इसका आंसर आएगा t half है 30 by 0.693. I exactly don't remember the answer, इसको करके देखना. I think it will be 43.29. ठीक है, is that clear? If it is clear, give a thumbs up. These questions we do not have time to do it now, but I told you about this common name of butan 1-ol, it will be n-butyl alcohol. ठीक है, please solve it and write the answers in the comments if you know. This question also have been discussed in detail. Normality of the solution, this अभी normality molarity बोल देंगे, so we will talk about that. This also is n1 v1 n2 v2. If you want, you please solve these questions. इसका solve करके आंसर डाल देना comment section में, I will check. If you have any doubt about any of this question, you can ask me, that also I will say. ये जो calculation है ये मैं नहीं कर रहा हूँ, this I will solve. Which of the following vitamin aids in blood clotting? Straight from that table, vitamin K. Beriberi is caused by which one? Beriberi is caused by what? यहाँ पे लिखा हुआ है beriberi. Beriberi is thiamine है ना? Beriberi is vitamin B1. Vitamin B1. Then, which of the following vitamins form a coenzyme function? Which of the following vitamins have a coenzyme function? Yes, both is correct. Actually, it should have been two correct because n-butanol, n-butyl alcohol, बीच में comma तो नहीं दिया है ना NTA ने. बीच में comma देना चाहिए था. There is no compound as such. If you are not giving any comma, it means n-butanol, n-butyl alcohol. ये कौन सा compound है? ऐसा कोई compound होता नहीं है. So it should be n-butyl alcohol is the perfect answer. लेकिन उस साल this was my JRF only 2023, they gave both 2 and 3 as correct. ठीक है, tell me this question, which of the following vitamins perform a coenzyme function? A, B, C, कौन? अरे अभी तक तो तुम लोगों का PYQ एकदम होटो में होना चाहिए था भाई. It should be in your fingertips. Still you are taking so much time. Why only vitamin B? All right. So that ends the session today. Now, please let me know how you enjoyed the session. ठीक है ना? And also let me know whether you need the normality, molality lecture or not. Then I will take that and I will go, because I have to leave the board for other mentors. Partially weathered bedrock is C or R. अरे यार NTA के आंसर की के हिसाब से तो R है ना, होना चाहिए C, but NTA has given R. I remember. क्या करे उसमें, NTA है यार, NTA का तो कुछ नहीं कर सकते. Whatever they say. Let me know how did you like the session, and also इसका correct answer is this only. ठीक है. I'm really sorry, I have to leave the session, and another class is scheduled here. So anyhow, I will be writing the normality, molarity and molality definition in the comment section of this video. किसी को अगर समझ में ना आए तो वो कमेंट में मुझे पूछ लेना. I will write it down there. बस ऐसे याद रखना, molarity is the concentration which is dependent on temperature and volume. Temperature बदल होने से. Molarity is number of moles per 1000 ml of solution. Molality is per 1000 gram of the solvent, and normality is number of equivalent per 1000 ml of the solution. So ये याद रखना, solvent and solution. I will write it in detail in the comment. उसको एक बार देख लेना. I think you will understand. Till then, all right. Good luck for your exam. This is the last time we are meeting. Again, we will meet on IRI or we will meet on the exam day. So thank you so much.